Hello everybody and welcome to Spindle TV. Hope everyone's doing well tonight. My name is Laney Shaughnessy. For those of you that are new, that might be new, that be popping in tonight, I'm Laney and I will be your host for the evening. Hopefully you're all doing well. It was a struggle to get here. I was so close to canceling class because things didn't fall into order the way I was thinking. As you know, tonight's topic, we're going to be discussing and looking at and working with some vector files, for metal inlays, inspired by the Woodsmith episode 6, where they talk about and they work with metal inlays for little jewelry box and things like that. Well, I ordered the metal and the router bits and everything, and then they didn't come in, and I wanted to have them in. I wanted them to come in, and so I could actually work with them and everything. So I could have just a little bit more to, what's the word? Talk about. A little bit more to talk about and things. But I have a lot to talk about. Don't you worry there. I got you covered. But I was hoping that the bits would have came in so I could have them to show off and everything. So what I've got some details that I can show you and talk about the bits and all that stuff, the metal, the silver, the brass, and everything, the aluminum and all, and just today was just a day of a bunch of customer calls, and it was like, oh my goodness, it was like right down to the last minute. Here we are at 7:17, and normally I'm starting a few minutes early because I've kind of got things in order. It was like, no, it was a tough one today, but we made it. We got it. We got good here, and we are ready to go. So let me get to. Bear with me just a second, and bear with me just a moment. Again, like I said, I'm kind of just getting caught up here. Let's see here. Sheet goods. Almost there. Hold on. We just get. It's been one of them days, ladies and gentlemen. One of those days. Let's see here. Silver sheet. And let's go to here. Go to here. We'll get going in just a second, ladies and gentlemen. Usually have all this kind of like ready to go. Give me just a quick few moments. Rio. There we go. Beautiful. Perfect. Okay, here we go. How are y'all doing today? It's been one of those days. All right, so let's jump over. Let's get into the software and let's kind of talk about things. Hopefully you're all doing well. It's been one of those days for me, and now I think I'm back on track. I'm ready to go. We'll get through this pretty seamlessly now that everything is going. So let's switch over to camera 2. Let's get me down in the bottom right hand corner. Let's fly down here. Shoot. Or left hand corner. Right? Left, yeah. No, left. And hopefully y'all can hear me, and hopefully you're having a wonderful evening, and hopefully you get something out of tonight's class. So right now I've got here on the screen, and let's talk about the muse for this. So last week we did the 3 arts and crafts tables, how to kind of, you know, bring the vectors that were provided by Woodsmith in their CNC Base Camp episode. We brought in the vectors, and we talked about how to lay out the vectors and create all the fillets and things like that to create those tables. And as I was looking at the Woodsmith CNC Base Camp, which it's a good episodes, guys, check it out. It was referred to me, you know, by, is it Mike or Mark? Please tell me, correct me, because it's been one of those days, forgive me. But it was referred to me by a customer, and when I was looking at the 3 tables, I saw this class, episode 6, this episode, on metal inlays. Now, the cool thing about the videos over there at Woodsmith and what they do is, you know, they're going to show a little bit of the CNC. They don't get into the design that much, you know, a little bit of the CNC, but they do get in, they kind of show some of the materials carving. And then they talk about the assembly of what the project they're doing and how they worked with the metals and what they recommend and things like that. And it's good information. And then they also provide all the DXF files that you want to use. Now, I'm not going to use their DXF files, but I do have them. So we can bring them in and take a look at what the 3 files that they did on their little jewelry box. I have some different vectors I want to work with because I want this to be a teaching lesson. I don't want to just regurgitate what they're doing and all that stuff, even though they're not discussing, they don't work with Vectric or work in Vectric. They don't really get into the layout, the design, or the tool pathing that much, you know, that much detail. So that's what I'm hoping that I can kind of pick up that slack for those that like those projects and everything. So let's take a look at the projects that they provide, and let's see here. Comes as a zip file. Beautiful. And let's go to, in Vectric, we're going to go up to import vector. And on the import vector, we're going to go into the file episodes, and you get the DXF files. They have like the box side DXF, you know, side 1 and side 2, the box top, you know, 1 and 2, and then they have the different inlays that they're doing. They did a flower inlay and kind of an oak leaf inlay and stuff, right? So we're not gonna work with their box inlays. I will bring them in and show them to you and everything, but we're gonna create our own box. I want to do a round box. And I want to do it in multiple layers because I want kind of a decorative band out of a different material to be cut. And I want to pick up with that. But let's take a look at their file. So box 1, and I'm just going to move all their stuff kind of over here. And let's import side 1 and 2. Okay. And then let's import their top 1. And, oops, click the wrong button. Let's import their top 2. And then let's import the floral inlay. And let's import the ginkgo leaves inlay. and the oak inlay, oak leaf. And then let's go ahead and that's it. Let's go ahead and open up the PDF that you get as well. So you can see at least what the CNC Base Camp files that they provide you. You can at least see kind of what you get with those files, and they do a really great job of it because, you know, let's bring this over onto the screen. Let's maximize this out. So the box that they created has no hinges, no locks or magnets or anything like that. Just a nice decorative box that has a lid that separates it. They got some finger joints going on there. And then they've got some inlays. And their box is about 5.5 by 5.5 inches square. And from the bottom to the top of the lid, you're looking at about 4.25 inches tall. And they, in the PDF, they show the box sides, you know, for the different views for side 1 in their measurements, side 2 in the measurements, and then, you know, top lid 1 and 2 and everything, and the grooves and everything. And they've done a nice job with the layout, the panels, the top and bottom panels. So they've done a really good job with this. And when it comes to the vectors and all, on these finger joints and everything, where these joints are going to, you know, be fitting together, those inside cuts that we talked about in last week's class, those inside cuts and everything, we need to create those fillets. And they've got a nice way of hiding the fillets, you know, in some ways. But when it comes to finger joints, there's not much in the way of hiding it that we can get. When we go to do the joinery and all, I think because Woodsmith's got a combination of, they work with, you know, hand tools and their CNC, you know, they don't just let the CNC do it all. I have not watched the video. I'll be the first to admit I have not watched the video on this one. Again, it's been kind of a backed up, you know, time. None of the parts came in, none of the router bits, and also I almost thought I wasn't doing this class. But I'm assuming that they've gone in and they've kind of cleaned up the fingers and everything and squared them up. Now, if they've done them in the on the CNC somehow or another, the only way that I could see doing it is doing dog bone fillets, but that's going to show the little bitty offset of that router bit icon in the joint. And the one thing from the video of the tables, the 3 craft tables, those are craft tables we did last week, you know, he's really keen on, you know, hiding the joint or working the tools necessary so we have a clean joint on the fingers. And I think he just went through and kind of cleaned up the corners on these. Very small radius bit to begin with to cut the parts, so there wasn't a whole lot of cleanup required. Some just a little bit of cleanup required, most likely. But what I want to take you guys through and do is, you have these files here. There's not a whole lot that's got to be changed with them and stuff, but I would like to create a brand new round box, fitted lid. It's going to be a 2-sided project for the fitted lid and the inlay and everything. So I'm going to be taking you through a 2-sided project, a round project. We're going to be doing an inlay, and we're going to be cleaning up some vectors and stuff with the inlays that I want to use, because sometimes not all the vectors are perfect and everything. We're going to be talking about the router bits and the sheet goods, the, you know, brass, silver, gold, and bronze and stuff. We're going to talk about the sheet goods and where to get it, one of the resources to get it from. and router bits, where to get them, and all that good stuff. So it's going to be a full class. Buckle up, ladies and gentlemen. We're going to be doing inlays, but if you want to kind of see what they've cut and how they put their box together and their discussion on the box, watch the episode 6. The link is in the description of this video, the link to their tutorial and everything, and these inlays. But we're going to start with our own project, because again, I don't want to just every week, if I'm going to kind of, work off this, I don't want to just regurgitate what they're doing. I want to give you the same tips and tutorials and everything. Our focus is the inlays, but I want to put the inlays in a really nice box, and I want to take you through that. So hopefully and Brooks Martin says he used a router to round over the fingers. Good. Okay. There you go. All right. So watch that video on episode 6, and let's go through and create our inlays and our box and everything, and let's go from there. So what I would like is, I've got a project set up here. We're going to go 5 1/4 by 5 1/4, basically kind of a 1 by 6, but I'm not going to just run down to, Lowe's or Home Depot or whatever, and I could do it in oak, right? But I'd like to have a nice walnut box, round fitted lid box. I'd like to have a nice accent strip. Maple, I kind of like the contrast of maple and everything. And on the lid itself, we'll discuss the metal and what metals we're going to use for the inlay and all. But I'm going to come out with a 5 1/4 by 5 1/4 diameter setup here, and 3/4 inches thick. I'm going to be working off the material surface, but it's going to be a two-sided job, okay? Not all of the parts are two-sided, just the lid. The lid's going to be two-sided because I'm going to be carving the fitted pockets and the lip and all that good stuff on the bottom side of the lid, and then the inlay on the top side of the lid, right? So it's going to be a two-sided job. I am going to reference off the material surface for each side. And I'm going to start in the bottom left corner, and I flip my boards. When I flip my boards, I flip them along the y-axis. Okay? So I'm going to flip along the y-axis, and that's going to be my job setup. Now, the first thing that I'm going to do is I'm going to lay out, and bear with me just a second here. I'm going to move these to a brand new layer. So right click and move to layer, new layer. And I'm going to call this Woodsmith box. Click OK. Now don't be disappointed that I'm not working with that Woodsmith box and everything, and and the joiners all. It's a very basic finger joint box. You can either clean up the inside of the fingers, or you can do fillets. You'll just have, they'll be seen and all. There's not really a lot to it. I want to take you through these. I want these to be lessons, right? So lessons in when you import vectors and stuff in, and what needs to be cleaned up and all. And those inlays, there was nothing that really needed to be done with them. So don't be disappointed, because we got a lot to go over, and we're going to learn something in this class. So we're going to start off with a 5-inch diameter circle. Okay. Now notice on the screen, I just put the mouse in the center of the board, and I've got smart snapping and geometry snapping on. So I got these crosshairs when I was at the center. I got these crosshairs on the board that showed me exactly where center was, and I could left click and drop that there. Now I could have also, clicked over here on the screen, and let's go with our 5-inch diameter. And then I could have gone over to the alignment tool and aligned that to the center of the project, right? Well, with the smart snapping and the geometry snapping, it's just as easy for me to, when I have my tool in here and I have my size and all, is just to go over and take the mouse where I need it to, and wherever I click is where the center of that center point, that's where that center is going to land. So I clicked on the center of that, right? So I want my box to be 5 inches in diameter. So the box, and it's going to be kind of like a tubular round box with a fitted lid, right? I would like the box, so I got a little ruler here. I'd like the box to be, to have some depth to it, right? So it can store some stuff into it and everything. I'd like the box itself to be between, 3.5, 4 inches deep. And I would like I said, I want an accent ring, if you will, in there of a different species of material. I'd like to have an accent ring and all, and everything that I think would look good, right? So this is going to be kind of the layout of my box, right? Now, on the box here, the inlay, right? I'm going to kind of work. I'm going to work my lid first, kind of get the lid and all the vectors kind of laid out, and then we'll start creating the necessary vectors for the others. Because on the lid, the lip, my inside of my 5-inch diameter box, I'd like to have a pretty decent wall thickness, not too masculine, but not too flimsy, right? So I'm going to offset inward. I'm going to use the offset tool here. I'm going to offset inward 3/8 of an inch. Okay, so in a sense, my walls, if you will, because when it gets pocketed out, and everything, my walls are going to be around 3/8 of an inch thick. Okay, not too bulky, but not too thin, right? For me, I think 3/8 is a good number. Okay, if you guys and girls are asking questions or anything in the group, I know you're talking amongst yourself and you're listening to me talk and ramble. But if any questions if you do have questions, do me a favor, because I look over every once in a while to the chat and everything, make sure I'm not missing any cool conversation. But also, if there's a question, I'll throw a question mark in front of your question so I see it. Or if you want to support the channel, you can also use the super chats and super stickers and everything, which are basically donations, and the super chats will highlight your comment with and it'll stay up for quite a while. And the super stickers are just fun little stickers that and all that revenue helps the channel and me do what I do. Okay, so we're going to go 3/8 of an inch on our wall there, and now I'm going to import the vectors that I want to use for the lid. And I've got some vectors. I've got some vectors here called floral pattern vectors, right? It was from seeklogo.com. And if I open this up, we have these patterns that I liked. I'm going to move them off to the side and we'll kind of focus in on them. I know it's hard to see with that dark gray background, but I've got these patterns that I want to choose from. And for my round lid box, right, I've got multiple ones and things and all. And the one pattern that I want to work with tonight is going to be this one here on the bottom right hand corner. Now these are already vectors. It was free. These were free from online seeklogo.com. They have a bunch of different stuff you can type in and search for vectors, and I basically just typed in floral pattern vectors, and this was one of the many options, right? And I like the different patterns because any one of these would fit very well on a rounded lid box, right? So the aesthetics and everything, any one of these would fit on the rounded lid box. And so this is the one I want to work with, and so I'm going to double click on it, hold down the control key, and I'm going to drag a copy over and over to the center here, and I'm going to make sure it is centered on my material. And I'm going to size it up to the size that I would like it to be. Okay. And what I'm shooting for here is, I just missed my size, but I'm trying to go with just roughly, it's not fully symmetrical, but you know, 3.5, you know, is where I want to be. And the reason, there's two reasons why I chose this particular pattern over all 6 of them. Because each one of these patterns and these vectors, you'll be able to see why they're free in a moment. They're not perfect or ready to go right out of the gate, right? So let's look at, well, number one, this is supposed to be a circle, right? It's not symmetrical. It's 3.5 by 3.46. So there's something off somewhere. It's not perfectly round, that kind of thing. And if we zoom in on this, and I'm going to really kind of get up close and personal and everything, but if we start to really inspect the lines and all, they are not by any means the best looking of vectors, right? The lines are, you know, there's not really anything smooth or clean about them. They've all got, you know, issues and things like that, right? So they've got humps and bumps and all that wonderful jazz and all that stuff, right? Hey, Big Daddy Fish, how you doing, buddy? So our first lesson is we're going to clean these up, right? Recreate what we need to recreate and things like that. And I'm going to show you some ways that we can do that, right? Cool beans. All right, so let's look at the first things. First, let's look at this main circle out here, right? So the first thing I want to do is I'm going to take a measuring tool, a measurement, based on my current size right here where I'm at. If I measure, I'm going to just kind of just grab a point somewhere and measure kind of best of my ability straight down, just to get kind of what my distance is, right? You know, 0.1567, you know, roughly around there. Now, what I want to do is I kind of want to recreate this, if you will. And so I'm going to add a new layer. Okay, this is where layers comes in really great, really handy, and all that fun stuff. I'm going to, since my vectors that are currently here right now are, I don't need to change or set them or do anything with them just yet. In just a second, I'm going to lock my main layer here so that I can't move the vectors or disturb them in any way and all that stuff while I'm working on the new stuff. Now the new layer is going to have a color of red. Hopefully you guys and girls can all see red tones. If you do have any color blindness, I do apologize. Just red kind of sticks out a little bit more on the screen, and you know, it's easier to see, especially when it's on top of something, you know, the black and all. So that's why I'm choosing that color. But that way I can take this object here, and I'm going to pretty much start from scratch, if you will. I'm going to lock my main layer. What that means is on my main layer, let me get everything on my main layer. Let me lock that. Is I can't select anything on that layer. It's kind of protected from me moving it, right? I'm going to be working on layer 2. So the first thing I'm going to do is I'm going to open up my draw circle tool. Hang with me, guys and girls. You're going to like this. It's a good lesson. I'm going to take my draw circle tool and I'm going to snap straight to the center of my project because everything is centered, right? And I'm going to drag a box out to the main circle. Now, if we look and everything, if we look here and all where, you know, our line where I drug that to, you can see that, you know, the original pattern just wasn't symmetrical, you know. I mean, just there wasn't nothing straight about it, right? So this is why I'm kind of recreating it, if you will. Now, from there, remember I took that measurement earlier. It was 0.15, you know, 67 and all that stuff. I'm going to do an offset of my circle. Hopefully you can see that red circle there. I'm going to do an offset of my circle inward of that 0.1567 and kind of bring that in, right? Kind of, you know, bring me into that, you know, about that same distance. I want to keep the, you know, the same kind of feel, you know, for it and all that stuff. But I'm going to bring that in. All right, cool beans. And now that I have that, if I were to look at this design, right, and I kind of look at, just like Vectric, virtually you don't see it in the background, but your project boards, all of them are broken up into quadrants: upper left quadrant, upper right quadrant, lower left, lower right. You know, no matter if you're starting in the bottom left corner or what, your board is always broken up into quadrants, 4 quadrants and all, when you're mirroring, flipping about job center and all that stuff. So if I'm looking at this, right, in my design, my pattern is supposed to be, you know, centered and everything. Then the dividers, right, these dividers right here between, you know, the left and the side and everything, I can see that they're just skewed a little bit, right? They're not straight. They're just skewed, those dividers and all. But I want to create the same fill, if you will, but I want to I'm going to use rectangles, right? So if I were to come in here and I'm going to use a rectangle, and I'm going to draw a rectangle all the way straight down here, square corners. Corners don't matter because we're going to be using them scissors and trimming and all that stuff. And I'm going to hold my shift key down and size this down to roughly where, you know, it's right about here, you know, right? You know what I mean? Just get it right about the same size, that same gap, if you will. Okay? Now, I'm going to make sure that that rectangle for me is centered left to right. That vertical, I'm going to go to the alignment tool, and I'm going to make sure it's centered left and right. It was off just a little bit, right? So now it's centered. And then I'm going to hit copy and paste, right? So copy and paste, Control C, Control V, if that's your thing, you know, keyboard shortcuts and all that stuff too. And currently the new copy of that rectangle is the one that's selected. So I can hit the number 9 key if I want to go clockwise, or the number 0 key if I want to go counterclockwise. Let me say that again. I can hit the number 0 key if I want to go clockwise, and the number 9 key if I want to go counterclockwise, but I'm going to rotate that part. I'm going to hit the number 0 key, so I'm going to hit it twice. 1, 2, right? So the twice when I click on this part, okay, that's going to turn it 90 degrees, that copy, okay? So now I have kind of this cross here, right? And to make sure that everything is on the up and centered and all that stuff, now that it's horizontal, I'm going to go into my alignment tool and just make sure up and down that it's centered, right? Okay, so there you go. Righto, righto. And so now that's centered up and down on the board. And then from there, and by the way, if you ask, well, wait a minute, why didn't it center when it rotated? Why wasn't it centered? Because I just freehand drew the rectangle, right? That rectangle is longer down here than it actually is up here, right? So from my center point, so when it rotated on the center of itself, which was just a little low, not the center of the material. So that's why I had to center it, right? That's why I had to bring it up center. So in case any of you were wondering that, that's the reason why. Now, now that I have this, I can use this to do some trimming. Now I'm going to turn off the background layer to get rid of all that confusing stuff in the background, right? I'm going to hide it so you don't have to see it for a moment. And I'm going to turn off the light bulb on that layer and that layer just so we can see our circles and our cross, right? And what I'm going to do here is I'm going to take the scissors and I'm just going to come in and start trimming, right? And then I'm going to trim there and there. I'm going to come over here, trim, trim, there and there. Down here, trim, trim, and side to side. Here, trim, trim, side to side, right? And so what I'm left with is essentially that shape, if you will. Now, each one of those shapes originally, the corners of the part, they were nice and filleted, right? You know, we could do a couple of things with the ends here. In node editing mode, we could turn that into an arc and, you know, pull it out so it's kind of a rounded end, but I don't want to do that. I just want to put a nice little fillet on there, give it a nice little rounded edge. So I'm going to go to the fillet tool and I'm going to go, let me see what a 1/8 inch normal fillet looks like. Way too much, way too much. Let's go 32nd, 0.03125. Nice. So a 32nd, right? And I'm just going to go through and add that little fillet to all of the sharp corners here. And I'm doing this now because why draw what you can copy and all that good stuff. We'll talk about it in just a minute. So nice little fillet, normal fillet, right? All right, cool. Now, if I turn the layer back on, right, of that design, just that pattern and design and all, now we have kind of these internal areas here. We've got our center circle here and all that stuff, you know. So I want to emulate what it is and all. And I'm going to eliminate that rectangle there in the middle. And I'm just going to take my circle tool, come to the center, and I'm just going to drag a circle out. And again, I don't care that the circle's not centered with the original. The original's off. It's all cattywampus, right? Is that a word? Is that a technical term, cattywampus? But it's not centered itself, so I don't care about that. My circle is centered, right? I just want to get round about the same, you know, size and everything, and it's showing about, you know, 0.385 and everything, and I'm just going to go 0.375 and about 3/8 there, and it'll be good. And again, I can't select anything with, you know, anything else here. And so I'm going to just leave that be. Now, on these remaining parts here, right, these arcs and stuff, and the leaves, we'll talk about the leaves last. But are you guys doing okay? Am I boring you? You liking this? Let me know. I saw a big drop on my viewership. It's just like, shoo, big old spike and everything. So let me know if you guys and girls are still good. But on these parts here, so look at the shape and what it is and think of the best way to approach recreating it, right? And in this case, it's an arc all day long, right? It's not necessarily the outside arc, right? You know, my first thought when I looked at this was, hey, why don't I copy and paste, Control C, Control V, and move that part out, flip it, if you will, right? Mirror it, if you will, and or rotate it around, however you want to do it. Rotate it around, and then size it down. You know, come in and size it. Hold that Shift key and size it down to kind of create, you know, that. Oops, I'm grabbing the wrong thing here. size it up to create kind of that part, right? And scale what I need to scale and all that stuff. And then if I need to adjust the curve a little bit more and all that stuff, then go into node editing and do it, right? That's one way, right? So you just seen it here. And again, if I went into node editing, I could come in and I could take these and pull them down, right? Kind of get them in line with that other one. I could pull this leg down to here, pull this leg, this leg down to here on this side. I could come over here and move those over to get them somewhat in line, right? And then I could take these anchors and pull this down to there and pull that down to there. And, you know, I have that shape, right? Or a very, very close simulation of it, right? Let me get this one pulled up just a little bit like that. So I have that shape and all, right? So that's one way. We could have done that. No big deal. But thank you for that. Thanks, Roger. I appreciate you, Roger. All right. So that's one way to create that shape. Now, second way, way number 2, let's go with our arc tool. And I'm going to click, I'm just going to pick a spot here. I'm going to come all the way over and around about in that same area, click a spot, and then I'm going to pull this up to a nice kind of shape that kind of, you know, pretty much kind of simulates that shape there. Okay. We with me? You with me? You with me? All right. And then I'm going to offset that outward. Okay. So, if I go into node editing mode, by the way, left is here, right? So I would actually be on the inside left. So I'm going to be going inward, offsetting inward. And outside right would go, outside would go to the right here and during the offset. So I want to offset inward that same distance. And it's not quite that 0.1567, that distance, but hey, you know, we're recreating it, but that's okay. I can back it off a little bit. So I'm going to undo that and I'll just go 150 and I'm pretty darn close there. Let's go 148. All right, I'm going to call that good for me. 148 is fine for what I want to do. And now I'm going to select both of those shapes and I'm going to join them with a straight line. Okay, so let's turn off this layer so you can see what's going on here. So I've got this shape here. I'm going to join it with a straight line. Okay, once, twice, click it twice so it joins on both sides. And my fillet, right, the fillet tool, that 0.03125, I'm still going to use the same fillet. And I'm going to throw that bad boy in there. Whoa. Now, notice when it did that, right? Wow. And everything. That's because when I joined here on this join, it's got a bit of a funk going on there. Let me do this side. There we go. And let me get on, I'm going to zoom in on this corner here, get right there, and that way it pulls up. When I was out further, I was kind of more hitting, instead of right on the corner, I was kind of more hitting the node over here, and it was just doing something wackadoo, right? You know, and everything. Undo, Control Z, and, you know, go through and try to figure out if it's an open vector or what it is. But in this case, what I had to do is I had to zoom in to get really right on, let me undo this, Control Z, to get really right on that corner. You know, I was over here and everything, and when I did that, it was throwing everything wackadoo, right? And stuff. So make sure that, you know, get right on that corner, get that little check mark and everything to get that radius that we want. Okay, cool beans. Here's the fun part. Are you ready, Freddy? All right, we're going to take that shape. We're going to rotate it around 4 times. We're going to rotate it around our center 0, 0, or, in this case, it's not 0, 0, because 0, 0 is the bottom left corner of my board, so it's 2 5/8 by 2 5/8. Rotate it 360 degrees 4 times, and we're going to copy that around to create that shape. What? Absolutely, right? Cool beans, right? Okay. You lost your symmetry. Maybe do another circle from the center and trim. James Stewart says, I lost my symmetry. James said, I lost my symmetry. And I think he's talking about the different heights and everything, the different positions and all, where I am, my size, right? He's wanting to be like perfectly symmetried all the way around. And all, and hey, that's good. So we can undo that, right? Come in here, and what if we go into our layout lines and everything? Let me snap to the end of this, and if I were to rotate, I don't need my layout lines for this. Basically, these are a little short, no big deal. And let me get a measurement. Length from here to there. 0.0893, and from there to there, 0.1232. So I need to extend 0.893. Let's do an offset. Let me put my math number back there. I'm going to do an offset of this part. I'm going to offset outward 0.1232 minus 0.0893 equals, and I'm going to offset that to there. And then I'm going to take my extend tool, and I'm going to extend that line to there. And if I were to rotate, bear with me just a second, I'm going to rotate this part. Give me just a moment. I actually want to go a little bit wider than that by row, so let's offset that outward. I'm going to go 3/8, 0.375. Whoa, that's way too much. Give me a second here. Let's go 0.125. That's good. All right. Alrighty, Aphrodite. Okay. All right, let's go in with our scissors and trim, extend, delete, join with a straight line, 1, 2, fillet tool, 1, 2, 3, 4. Wrap it around the 0, 0. Okay. All right. Better? Better? Is that good? Good. Cool. All right. Now, what James is throwing out there in the chat is he's saying take a circle from the center, right? Take a circle from the center, and I could bring that circle out to the edges. Here, let me snap to the edges. I could bring the circle out to the edges to keep my symmetry. Okay, so that and that, right? I'm not going to bark too much about that, but if I wanted to, let's do this, right? Trim, right? So we can come in here, size this circle down just a little bit, take our scissors, oops, trim that away, that away, that away, that away. Trim that, and that. That, and that. And that, and that, and that. And then go back in with our fillet tool. And 1, 2, 3, 4. So we could do it that way too. And that's what, when you guys see James is coming about, put a circle from the center, that's what he's referring to, right? We have our arcs, draw a circle from the center, use the circle to trim so it keeps everything nice and symmetric, and all of that happy jazz, right? Cool beans. Thank you, James. All right, all these little tips, right? So lots of ways of doing things, you know, and there we go. Right, so we still copied around. Done deal. Okay, now let's turn on our layer again. Okay, now we have these kind of leaf patterns, if you will, right? And from these leaf patterns, our little shapes are trimmed back away from that. Show you how to do that too. It's just an offset and all that good stuff. Now, your little leaf shape, whatever you want it to be, can be anything that you want it to be, right? Whatever it is. For me, I always look at, for me, when I'm approaching design, and if you've ever watched any of my classes in the past, especially the Maltese cross, how to draw a Maltese cross using guidelines and everything, I look at everything as what shape would I start out with to create the shape that I want. In this case, I'm going to start out with a rectangle, and from that rectangle, with some node editing and everything, I'm going to end up with, this kind of floral pattern, if you will. It doesn't have to be exact, but, close and everything. Excuse me, I had the hiccups for a second. All right, and so what I want to do with this is I'll go ahead and use the circle tool. Remember that back layer that I keep turning on and off, it's locked. I can't mess anything up with it and all, and I don't care if I mess it up. It's not that pretty. That's why we're redrawing it. I just want you guys to see that, it's not the end of the world if you can't find the perfect graphic and all. Get close enough and go in there and spend a little bit of time and clean it up, right? We're going to have a really nice inlay graphic that's going to be great. It'll look great as metal and all. We'll talk about the metal and all that stuff in just a second. But let's go ahead and I'm going to take my rectangle tool, right? And I'm going to draw a rectangle. And I'm going to take that rectangle and I'm going to kind of bring it in and kind of get it somewhat roundabout, centered with the object that I'm trying to trace. And I'm going to go ahead and rotate it, kind of get that shape and all. And what I'd like, since it's more kind of a 45 degree, right? I'd like to be a little bit, keeping with James's thoughts and everything, of keeping things symmetrical and everything, since it is, every four corners, right? Which is basically, those four ways all the way around. So I want to, if I hit the number 0 key, I'm actually rotating that part counterclockwise 45 degrees, right? By 45 degrees. And then from here, now I can go into node editing and I can start to reshape this rectangle into the shape that I want. So we're going to go into node editing, and I'm going to just take this node here and kind of drag it, this node right here, and I'm going to kind of drag it over. I'm going to take this node up here. Let me zoom. Let me get this on the screen. Let me get this on the middle of the screen right there where everybody can see it. I'm going to take this node and I'm going to drag it over this way. Kind of start getting, it's all straight lines right now. I'm going to smooth everything out with curves and all, but start getting, that general shape going on. Bring this one over, right? Kind of start getting that, almost like that triangular shape, if you will, and everything. And now this shape is a gradual curve, right? It's a gradual curve and everything. And so when in node editing, I can take a span and I can turn it to a Bezier curve. I can turn it to an arc, whatever the situation calls for. In this case, I'm going to turn it into an arc, and I'm going to pull that arc back. It likes to, when you turn something into an arc, it likes to shoot out into no man's land. And you just got to tame it, bring it back in and everything. But I'm just going to pull this out, kind of get that arc shape going on here. And now I'm going to show you a cool trick. I'm going to kind of focus on one side of this. Again, symmetry, right? I'm going to kind of focus on one side of this, and then I'm actually going to mirror that over to do the other side, so it's a symmetrical kind of part. Or if you don't want it to be symmetrical, you want it to have some differences, it can do that as well too. But I'm going to kind of focus my attention on this top half here. And so from here, I'm going to pull this node down to here. I'm going to insert another point here. Right click and insert a point. I'm going to kind of pull that there, and I'm going to turn this into a bit of an arc. Not that dramatic. Pull that back. Okay. And then I'm going to come over here and put in a point and pull that down to here. I don't care, right? Again, everything is kind of straight lines right now. I'll go in and smooth everything out in just a moment, okay? I'll go in and smooth everything out in just a moment. I'll show you how to do that. I'm going to come in here and I'm going to grab, insert a point and pull that up to, here. And then from there, I'm going to right click and I'm going to kind of delete the span. Oops. Hold on a second. Let's try that again. Delete the span. That separates it, from here. And I'm also going to delete the span down here. So I'm only working with this 1/2. So we'll get rid of this line for right now. And what I want to do is I want to kind of start, shaping my half. In node editing, I'm going to turn this into an arc. And again, not so dramatic and all. And I'm leaving this intentionally long. You'll see why in just a minute. I'm leaving this intentionally long down here, but I want to kind of, somewhat start. And again, we're working with bad lines, cleaning them up. So don't try to match them exactly. That's not the goal. The goal is to make it better, right? So I just want a nice arc, a nice flow to this leaf and everything. Now right here, got kind of a bit of a hard spot and everything. Well, I can select these nodes and I can hit the letter S on the keyboard, and I believe, is it S? Is it S? Hold on a second. What is my keyboard shortcut? Bear with me for a second. It is S, the letter S, but it is not why it's not letting me deal with that. All right, so let me delete this point. And I'm going to make this a Bezier curve. Still not going to let me smooth it out. Well, son of a gun, you. All right. And I'm going to pull this. I want a bit of a flow to it. I don't want it to be, you know, so hard that there's not really a lot of flow to it. So I'm going to, oops, don't do that. I'm going to grab just the anchor and kind of pull this up. And I'm going to flow into here. Create my own little smoothness. And then from here, that one's not going to let me smooth either. Oh. You bugger. All right, I'm going to make that a Bezier curve. Okay, now let's turn off that layer. Okay, and I want to smooth this out a little bit. Now, the smooth, there it is. Had to go out and come back in. But I can hit the, when I have the nodes and everything, generally I can, you know, select all the nodes and I can hit the letter S on the keyboard and it'll smooth them out, right? If I wanted to do them all at one time, which it just did, you know, kind of thing. I don't want to do them all at one time. I want to do this one a little bit. I want to smooth that a little bit. Don't want it to be so, oops, I hate when I do that. I don't want it to be too thin here. So I want to give it a little bit of thickness. Okay. All right. So I just want a nice little flow, if you will. Okay. Now, I'm going to come in here and I'm going to I want to mirror it, right? But how do I want to mirror it? Well, I want to mirror it about a line. Are you guys and girls still with me? Wake up. All right, cool beans. We're going to go, I'm going to start from the center. And I'm going to draw a line, you know, 45 degrees, right? And I'm going to take this shape. I'm going to select that shape. I'm going to select this line. And then I'm going to go into the mirror tool. And I'm going to click the button that says create a mirrored copy. And then flip about line. Right? Right. Okay. Create that symmetrical half in there and everything. Now that I've done that, I can go ahead and get rid of this. And up here, these two parts, I'm going to join them with a smooth curve just to finish off that little point. It's not the prettiest point in the world, but it will that looks worse. Bear with me. There we go. Okay. So now that I have that, right? Stay with me. Here's where it gets exciting. I'm going to take this circle here. Let's get out of node editing mode. I'm going to hold down my control key and I'm going to hold down my shift key, control and shift. And I'm going to grab this corner box and I'm going to drag a copy out. Not going to go out too far or anything like that. Just a little bit right there. And don't let go like I just did. Don't let go prematurely. Hold that control and shift and drag that out. Let go of that mouse first before you let go of your control and shift button. But I'm just doing kind of an offset, right? No particular rhyme or reason. Just add a little offset there. And I'm also going to do an offset of this guy. So I'm going to offset outward, and let's see what an 1/8 of an inch offset looks like. That is a little bit too much for me. Let's go a 1/16, half of that. I'm going to be happy with a 1/2 inch offset. Now, I'm going to take this shape, not that one, just that one, And I'm going to rotate it around 4 times, right? Circle copy tool. I want to copy around the center of my part 4 times, and I want to copy that around. With me? Cool beans. All right, now here, and here, I can manually do this. I'm going to show you the way to automatically do it with the trim tool, but you can also manually do it with the scissors. I'm going to show you both ways. The first way with the trim tool. So I can select this shape, this, and this, and group them together as one, right? And I can select, let's not do that. Let's do one at a time. Oops. I can do this shape and this shape. We're going to do them one at a time. So select this shape first, then the little leaf outside boundary. And I want to clear inside that boundary. And when I do, it's going to redraw this shape around that boundary, right? Then I can come in and delete that offset and have that shape, right? Remember, if we turn on our design, right, those parts were kind of cut off on the edges there. Same kind of vibe, right? Same kind of vibes I got to fill. So that one's done. Here, select what you want to trim, the boundary you want to trim last, and clear inside that boundary. And then, of course, we don't need the boundary anymore. So that's using the trim tool. I can also do that, obtain that same thing by using the scissor tool. Excuse me. With the scissor tool, I can come in here and trim. Over here, trim, and then get rid of the stuff that I don't want, right? Same vibe, right? So once again, trim away what I don't want. That kind of thing. And just make sure that you get rid of, if you're using your manual trim tool, your scissors, get rid of everything that doesn't belong. Okay? Good, we good there? All right, now in here I will use the trim tool. What I'd like to do is I just want to cut off these points here and get that around. I want to kind of create that little arc right there, right? Get that tip out of there too. Get that tip out of there too. Trim that away. Get rid of that tip. Trim those 2 lines and the big line in between. Get rid of that tip. Get rid of this line and that line and those 2 edges. There and there. And basically, I wanted to create kind of that nice little arc that kind of matches kind of the offset of that circle, right? And there we go. So if we look at our original, okay, I'm going to take our, remember I can't select the original, but I can select what I just created. If we look at our original versus what we just redrew, much cleaner lines and smoother and all that good stuff, right? The red is the one we just drew. So not too difficult. Our leaves don't look 100% the same, but that's fine, right? Right? So I got a little bit more flow in my leaves, a little bit more curve in my little flowers versus kind of these, hard cornered lines and stuff. So, but that's what we just created, right? Cool beans. Okay, let's go ahead and get past all that stuff. Lord have mercy. All right, so now we have our new inlay. And don't both spans around nodes have to be Bézier's to smooth? I don't know if that's the case. What someone's asking is on a span, if I go into node editing mode, okay, see, I have a straight line here, straight line, and it allows me to smooth that point there, right? So, and it turns that into a Bézier curve on both sides and all when I smooth that point. So to answer the question the way you asked it, do both spans around the nodes have to be Bezier curves? No. They turn into Bezier curves. You know, when you're smoothing, that's what you're creating. You're not creating arcs, you're creating Bezier curves. But they don't have to be that way to begin with. Right? Okay. Cool beans. All right, so this is going to be our lid here. Again, this vector is, let's turn off the lock. Let me unlock my main layer here so I can select those. All right, this main layer is going to represent the inside of my pocket and all that good stuff. Now, I'm going to set up multiple sheets here. I'm going to set up a new sheet, sheet 2 and sheet 3. Sheet 2 is going to be a 1/4 inch thick. Okay, it's going to be a 1/4 inch thick. I think a 1/4 inch will look good, and it's going to be my accent piece of wood. So I'm going to cut out that accent piece of wood that's going to get glued. You know, I'm going to have my base. I'm going to have that accent piece of wood ring, the ring. Then the top, not the top, not the lid, but the top of that, they're going to be glued together. So I have that nice accent piece and everything. And then I'm going to have the fitted lid, right? So I think the ring, I think it's going to be a 1/4 inch. Yeah. Okay. So basically, let's come back into here. These two shapes here, they're going to get copied to sheet 2, and they're going to get copied to sheet 3. Okay. And I'm going to designate sheet 3. That's going to be my bottom, the actual base of the box, right? The bottom part, right? So I'm going to rename that to the box bottom. And let's see here. 3/4 and a 1/4 is 1 inch. And then my upper part is 3/4. I need one more sheet. One more sheet. So I'm going to add a new sheet. This is going to be my sheet 1 is going to be my lid. So we'll rename that to lid. Sheet 2 is going to be my accent ring. Sheet 3 will be renamed to my upper tier, upper level, upper part of the box. I'll just call it upper tier. That's fine. Yeah, I'll know what it is. Now on my upper tier, so 3/4. Then I'm going to have an accent ring, and then I'm going to have another piece on top of that, and then the lid on top of that. Now, the other piece on top of the accent ring, do I want it to also be 3/4 so that way my ring is somewhat in the middle of the box? I think that would probably look more aesthetic. I kind of almost want the ring to be a little bit higher, so I'm thinking about the upper tier being a 1/2 inch thick piece of material. Let's do that. So the upper tier is going to be a 1/2 inch thick. And don't worry, ladies and gentlemen, if you don't have planers or anything like that, your CNC does surfacing, but also on your cut, you can surface or pocket down, in this case, a 1/4 inch, and then cut your, your parts out, right? And it would be a 1/2 inch piece when it's all said and done. So once again, I need to go into here, and I'm going to take these two rings and copy them to the upper tier. So copy them to sheet upper tier. Okay. All right, let's start with our bottom of our box. Okay, very simple pocket cut. Okay, bottom of the box is going to be our pocket cut here, and we're going to go pocket. I'm going to, it's a 3/4 inch piece of material. I'm going to pocket down a 1/2 inch and leave the bottom a 1/4 inch thick, right? So 0.5, and I'm going to use a 1/4 inch end mill. Do it as an offset, be a nice clean cut and everything. I don't necessarily, doesn't need to be a bowl and tray bit or anything like that. I don't necessarily need, you know, the rounded edges at the bottom of the box. All this is just going to be a container, you know, a container with a lid on it, right? And I'm looking around like I have something that would be similar, but it's not like a bowl or tray. I don't need a special bowl and tray bit or any of that stuff. I'm just gonna, you know, have that pocketed out. So this is going to be my bottom pocket, 0.25 end mill. Okay. All right. We're going to do the lid last because it's a 2-sided project and everything. So, and it doesn't take long. We're about to get there. Tonight's not going to be a very long class. Upper ring. Thank you, Jeff Berklow. I'm going to rename that to upper ring, not upper tier. Thank you. Thanks, Jeff. Did anyone else catch that? Spans. Looks great thing. No, Jeff, you're the only one that caught that upper ring. That's great. So that's going to be kind of our bottom of our box there. And we're going to have a profile cut. Right? Now, these are only 5 by 5, and there's not a lot of major cuts happening with them and stuff like that. I have room in the corners if I wanted to, but I mean, I could almost use a brad nailer to nail this down, you know, brad nail, pin nails or whatever, brad nails to my wasteboard. I could use double side tape, you know, and all that. I could throw clamps on there, of course, right, and everything. So I don't have to do tabs and all. It's only 5 by 5, you know, 5 1/4 by 5 1/4. It's not very big. I'm just going to throw some double side tape or painter's tape and CA glue if that's your stick, you know, if you like that and all that, because I don't want to deal with tabs, right? I've already got on the main lid, I've got to flip that and everything, right? So I've got alignment pins and stuff to deal with that. But for these, I don't want to deal with tabs or anything, so I'm going to use double side tape. So on my profile cut, it's just going to cut 3/4, 0.75. I'm going to use a 1/4 inch end mill. I'm going to be cutting on the outside of the line. I don't need tabs. I'm not too concerned about ramps or anything, but if you wanted to, you know, if you wanted to do a ramp, you could do a zigzag or a spiral ramp. A spiral ramp, for those of you that are new to Vectric and everything, basically from start to finish, it goes around and down like a toilet bowl flushing, you know, like the water goes around and down at the same time. It's moving down just a few thousandths of an inch as it comes around. You know, it's slowly dropping, slowly, and it's continuously dropping. And it's dropping at the same rate as it is moving. So when you're doing your feed rates, if you're going to do a, you know, profile cut and you are doing a spiral toolpath, then you need your feed rate and your plunge rate to be the same thing. So don't have a feed rate of like, you know, 100 inches a minute with a plunge rate of 10 inches a minute kind of thing. It doesn't work. Because then it'll be stop and stop, you know, stop and stop, you know. It needs to be a nice, smooth, you know, funnel, if you will. So have your feed rate and your plunge rate the same thing, and just it's going to drop slowly as it goes around until the part's cut out. Okay. I'm not going to do any kind of ramp right now. This is just a simple cut for me, and so we're going to go profile, cut out, cut out. And I'm going to put the word bottom on there, bottom, even though the sheet's named bottom. And also it's a 0.25 end mill. So those two toolpaths can get saved together. And they can get cut out, right? So that's going to be my bottom ring, now let's go back over to the sheets real quick and let's change that. We're going to go to rename that upper tier, and we're going to call it our upper ring. Thank you again for that. Upper ring. And that makes sense because I have an accent ring there, right? And then the bottom, we can, it's the box bottom, but it's also the bottom ring, right? It's not really a ring because it's not through, so we'll leave it at box bottom. All right, so very good. Now, this will be our box bottom. We're going to glue the accent ring to that, and then our upper ring gets glued to that, and that'll make our base of our box, if you will. And now the upper ring, okay, my lid, the upper ring is going to have, we got some extra vectors to do with it. Let's do the accent ring first, the 1/4 inch piece of material. And again, it's probably going to be, for me, like a piece of maple. And I'm using 2-sided tape, so the software is pretty smart, guys and girls. Now, I did a pocket because that one was, it was pocketed down. It wasn't cutting all the way through. This little 1/4 inch ring is cutting all the way through. Now, I have an outside vector and an inside vector. I'm going to do a profile cut on both of these vectors here. And it's only a 1/4 inch thick, so I'm going to be cutting a 1/4 inch deep. And I'm going to be cutting on the outside right of the line. Now, I'm choosing outside right because that's what I need the bit to cut on the outside right of this profile. But the software is smart. It knows that there's also an inside ring. There's a vector inside of a vector. And therefore, it's going to reverse that cut for the inside vector, and it's going to cut on the inside of the line. So I don't have to create 2 separate toolpaths. One for the outside and one for the inside, and I don't have to choose 2 different, options. I just need one toolpath, profile cut outside right, and for the inside vector, and it'll cut it first, but it's going to reverse that cut and do an inside cut. So when we calculate this toolpath, this will be my accent ring profile cut. Let me get rid of these spaces, backspace, and 0.25 in mil, 0.25 in mil. All right, when I calculate this, if we go and look at the 2D view, I'm going to go here. First, I'll go in wireframe. You can see that the arrows and everything, the direction they're pointing, they're cutting on the outside of the line, and then on the inside vector, they're cutting on the inside of the line. If I turn on solid view, so you can see those 2 cuts, the inside cut is cutting on the inside of the line, the outside cut is cutting on the outside of the line. Okay? Cool beans. So the software is intellectual that way. All you have to do is select both vectors and create that profile cut toolpath, cutting on the outside right, and it'll opposite for the inside vectors. Always, this doesn't have to be circles. I mean, anytime you have an inside vector and an outside vector and you're doing a profile cut, it's always going to reverse for the inside vector. Okay. So, just a simple, if we go into the 3D view here, profile cut, preview the visible toolpath, which is right there. And that's going to just cut out. And again, I have double side tape, right? So I'm not worried about tabs, and I don't want to be dealing with tabs. And also simple box, but it's going to be a nice looking little box, a nice little heirloom box. Who knows, right? But that's going to be my accent ring. It's going to be maple, and it's just going to kind of, I'm going to have a really dark walnut, and it's just going to be a nice accent ring. Now, you really want to get fancy, right? We're talking about metal inlays, okay? What if I wanted a nice thin, my metal is going to be 22 gauge. We'll talk about that. And while I'm mentioning metal, let's look at the resource. So one of the resources for the sheet metal the metal goods, is Rio Grande, riogrande.com. It's a jewelry supply house. And the sheet goods they have are silver, gold filled sheets, copper, brass. They have other metals, some unique, other metals and stuff. Then they have strips, and then they have foils, foil leaf and everything. I ordered some silver sheet, copper, and brass for these projects. And I believe that my box is going to have, I'm going to do the silver on the lid. But if we open this up, riogrande.com, okay, that's one of the resources and stuff. But, they have the sterling silver. They have different types of silver, right? And I'm just going to go with you can go silver, fine silver, Argentinian silver and all that stuff. I'm going to go sterling silver. And the gauge that I want is 22 gauge. That's going to be an easier gauge to cut. And it's a very good thickness and everything. We're going to let's see here. What is it? It's about 28 thousandths of an inch thick, 22 gauge is. In the article on Woodsmith, the article, episode 6, where they're talking about metal inlays, there's different thicknesses. There's 20 gauge, 22 gauge, 24 gauge, and all that. 22 gauge is just a good all-around sheet, and that's what they like as well, too. And I'm going to tend to agree with that. You want dead soft as the option. That's going to be an easier metal to cut. So you want dead soft to cut. And then you have your different sizes, right? So you can do 3-inch by custom size, 3x3, or 6-inch with custom size and stuff. Now, silver is a 3x3. And if we look at let's go back to Vectric here really quick. My inlay is going to have two, let's see here. Let me look at the size here. We are about 3 3/8, right? 3 3/8 by 3 3/8. So we need to go to the next step up on the sheet, which I ordered the 6-inch plus sheet. But I was thinking about doing 2 different metals. I was thinking about doing my silver for the petals in the center, and then all of the arcs and all, I was going to either do brass or I was going to do the copper. I feel that the copper would be a little bit too dark because it's walnut, and it's going to be a dark walnut. It really won't stand out. The silver is really going to stand out. So I kind of, during this class, while I was drawing and all, I was thinking that, all silver would look really good. Yet, when I look at the Woodsmith video and everything, I believe they used copper in a walnut, and it didn't look too bad and stuff. But I'm thinking about going all silver. So let's go back really quickly to here. And so now these are precious metals. I mean, then you got aluminum, right? You can do aluminum. You can do an aluminum. You would find that from a different. They don't have on the aluminum sheets here. But this is either real gold, which gold. I'm not doing gold because they charge you by the penny weight. So it can get a little expensive because gold's expensive right now. That's why they have Gold Rush on TV, right? But silver is not that much cheaper. I mean, it's $42 for that sheet and everything. That's just for the 3x3. The 6, and I went 6x6. I went square and everything. Not 6 feet. Holy camoly. 0. Woo. You know, troy ounces, you know, and price per ounce and all that stuff. You know, it's not cheap, right? So it's a precious metal. And this is why those super chats, ladies and gentlemen, that's why they help. Those super chats help pay for stuff like this. The the aluminum, of course, would be cheaper. Copper sheets, or you know, you can make your design smaller. 3x3 is not very expensive, $42. Copper sheets, 6" by 12", right? $14, right? So I have a couple of those coming, and unfortunately they didn't all come in, and that's why. And here on your metal types, you got nickel, brass, titanium, bronze, right? So you got you know, different metals and stuff in there, and all. But yeah, just be careful. I mean, gold filled is going to be a little bit cheaper than real gold, and all that stuff. I'm staying away from the gold. You know, the silver, you know, give you a heart attack. But I think it's going to look really sharp with the dark walnut. But anyway, what I was saying was, before I led into this, is imagine, right? Imagine that our accent ring wasn't a piece of 1/4" maple. What if we had a nice thin accent ring of our brass or silver or gold or what have you? Now, if I'm going to be cutting a ring, right? If I'm going to be cutting a ring out of the 6" by 6" piece as an accent ring, you darn well better believe, to minimize my waste and maximize my yield of that piece of material, because it's precious metal, right? I'm going to be, you know, finding other inlays and stuff that I can get out of that inner piece and all that. And I'm using a 1/16 of an inch bit. We're going to talk about router bits next here. But I'm using a 1/16 of an inch bit to cut it. So I'm minimizing kind of my waste as far as what the router bit's cutting and all that. But you better believe I'm not going to, you know, when I cut that ring out, I'm going to have my outside piece with, you know, a hole in the middle, and then I'm going to have my center piece and then the ring, right? If I were to do that. Well, that part's going to get used every which way, you know, Sunday. But also, you know, I have a little forge. I could melt down, you know, the remaining stuff and make something else cool, a little piece of jewelry or something with it too. So, I mean, there's no such thing as waste in the shop, but, you know, you can go there. But anyway, coming back, let's back up, Jack. At first, I wanted to do, like, you know, the silver leaves and the flowers, and I wanted to do, you know, something other than I was thinking, you know, brass, because it was a little gold. It wasn't gold, but it's a little brighter on the walnut. Have the brass, have that two-tone. That would look really nice. But I think I'm going to just go with the whole thing as one on this. Now let's talk bits really quickly and everything. But accent ring that we, you know, the accent ring that we just cut out, I'm using maple, right? But it could very well be that piece of metal, right? All right, so let's talk about some things that we're going to need for this project. Okie dokie, okie dokie. All right, so let's come over here. The first thing that we're going to need most definitely is some MDF scrap. MDF. The second thing that we're going to need is some Type Bond hide glue. Run down to Lowe's. I mentioned it to you in the class 2 weeks ago. But get yourself some hide glue. Hide glue has a reversible bond and everything, and the bond kind of dissolves with water, right? So we're going to, on the metal, to make it easier to cut and easier to handle and all that stuff, we're going to take our metal sheets. We're going to glue them to MDF background. We're going to glue them to an MDF background. That way when we cut, that metal sheet is secured from, you know, bending, moving, and flexing and all that stuff, you know, so our inlay gets cut out really nicely. And we're going to glue that metal sheet to that MDF with the hide glue. Okay? It's going to create a nice bond. The great thing about it is after the cuts are complete, we can throw that piece of MDF and metal into a bucket of water. a little tub of water, a little Tupperware of water, whatever. We can throw it in some water. The MDF will soak up that water very well, and the hide glue will dissolve. And the bond will separate from the metal from the MDF. And then we have our metal inlays ready to go, right? So hide glue is a great choice, and they talk about it in the videos on episode 6. It's a great choice because of the fact that it has that reversible bond and it breaks down with water. Okay, so an MDF is great as a backer board because it soaks up water like a sponge. And so once we do our cuts and everything is cut and done, then we can just throw that in a tub of water and separate our metal from our MDF, and then have our metal, clean up our metal and stuff, and get it ready for the inlay, right? The cut that so that's tight, that's our hide glue, that's what we want to use, right? Now the router bits that we're going to use, okay, we're going to use one of two different types of bits, or two separate types of bits, whatever. The first one, we're going to do a 1/16 of an inch diameter shank with a 1/4 inch cutting height. So, you know, typically we're trying to find bits with a longer cutting flute, to carve this out and all. But the longer on these thinner blades, on these thinner bits, the longer flutes makes it a more fragile bit, easy to break and stuff like that. So 1/4 inch cutting height, 1/16 of an inch diameter. A 2 flute bit is good for cutting metals like aluminum and stuff like that, so that you can use a 2 flute upcut spiral for cutting like aluminum and things. So that's one option for the bits. The other option is an O flute bit. An O flute bit, 1/16 inch O flute bit, 1/4 inch shank. This one is ZRN coated, and the O flute bit has this nice little fingernail. It's great for cutting out chips, and this will be great for cutting out a variety of material. Now, this particular O flute bit that's on the screen here, this is the Mana. It's the 51488-Z solid carbide O flute bit for aluminum cutting. 16th inch diameter, 1/4 inch cutting height, 1/4 inch shank. It is ZRN coated, and with that ZRN coating, it allows you can cut wood with it, you can cut plastics, you can cut metals, but the primary metals, it's an upcut. The primary metals it's great for cutting for is copper composite, your CCM, Alakbond, aluminum 5062, 6061 airplane grade, aluminum composite, ACM, aluminum composite panels, brass, copper, Dibond, Durabond, E-panels, gold, non-ferrous metals, plastic, silver, solid surface, titanium, and wood, right? So that one bit will carve all those different types of metals and everything, and you know, the O flute bit's kind of a good way to go. When it comes to the 2 flute bit, bear with me now. Okay, the 2 flute cutter, we are using an upcut for both of these. Just to give you a quick little lesson, or not a lesson, you know, and all that, but you have straight bits, upcut, downcut, and compression, right? So the advantages, disadvantages, and suitable materials, right? So an upcut bit, you know, it clears chips from the kerf, it creates a good quality bottom cut when cutting through, and on the bottom face when cutting through, and it allows for faster feed rates than a downcut spiral bit. Disadvantages is it can cause some chipping and fraying at the top of the material. The upward force causes the part to lift a bit, right, via the bit. So the bit's trying to always pull that part up, the upcut spiral bit, right? But the upcut spiral is good for plastics, aluminum materials, or any other materials, solid woods and all that stuff, but any materials where heat buildup is a concern, right? So your upcut bit. Your downcut spiral bit clears the chips, you know, kind of pushing them down. It's got a good edge quality on the top face, and the downward force helps, you know, when you're cutting thin sheets, it helps keep that downward force down instead of causing those thin sheets to flex, right? So it's kind of, it helps kind of keep those force down. Now, the disadvantages of a downcut spiral bit is the downward force. It does help with cutting the thin sheets, but it could cause some chipping or fraying on the bottom face, chipping and blowout, and it does require slower feed rates. And sometimes if you're doing pocket cuts with a downcut spiral, because it's always trying to lift itself up, it's pushing down, but it's lifting up and everything, it can leave little uncut areas at the bottom of the pocket cut, which would require like a little cleanup pass and stuff. The suitable material would be, your plywoods, MDF, laminates, hardwood, softwood. And when you're pocket cutting, like when you're doing joinery, downcut's the way to go because it creates that nice joinery edge. When two parts have to fit together, it creates a nice clean edge on those rabbet statos, grooves, and stuff like that. Then you have your compression bit, which we're not really dealing with this metal inlay. It's designed for veneer cutting, very thin veneers or plywoods and things, it requires a deep first pass or cutting at full depth, right? It creates a clean edge on the top and the bottom. There's really no disadvantages to a compression bit, but it does require your machine to be a little bit rigid in itself because that first pass has to clear that upcut portion of the bit. Sometimes that's more than 1/4 of an inch per pass, or you're taking the full cut in one pass, and everything. And some machines just aren't rigid enough to handle that, so you would have to do it in a couple passes. But that first pass has to clear that upcut portion of that bit, or else it's kind of pointless to use. This is great for plywoods, laminates, MDF, hardwood, and all that stuff. So anyway, we're going to be dealing with upcut spiral bits and our O-flute bit and our 2-flute bit. And that, by the way, that 2-flute bit was a speed tool bit available on Amazon. I don't know exactly the number. I think it's the SL1500, but it's a 1/4 inch shank, 1/16 inch cutting diameter, 1/4 inch cutting length. You want that short length for when you're working with the metals and stuff. Okay, cool. All right, so for our bits, now for me, I ordered one of each of those, but I did on the speed tool one, I did order 2 of those because I wasn't quite sure, even though it is good for aluminum, metal, and stuff. The 2-flute upcut spiral and all, just in case a break a bit or whatever, But here's the deal: your pass steps, you're only cutting 0.02 per pass. Now that's still enough because the material itself is only 0.028, right? So you're still going to cut all the way through in 2 passes, and everything, through that thin, metal material. And but 0.02 is going to be your cut depth, and you're going to be traveling around 35 inches per minute. 18,000 RPMs on the spinning, 18,000 RPMs. And again, the article, I don't know if he mentions it in the video, but in the article, the little write-up they did, the article explains a lot of this stuff and everything to you, and the cut depths and the RPMs and all. But 20,000 7-inch per pass, and your cut depth is 20,000 of an inch per pass, and your feed rate 18,000 RPMs, and your feed rate's about 35 inches a minute. All right, give me just a second. Somebody asked a question. Let me see if I can answer it really quickly. Copy. Stand by. Paste. Faster, faster, faster. Come on. Faster, faster, faster. Hurry, hurry, hurry. Okay. Someone asked how much the Amana bit was. It's $45 on 47.55 on toolstoday.com. Okay. You might be able to find it cheaper on Amazon. I don't know. Tools Today is kind of a, it's a good go-to for a lot of different bits and everything. They carry all Amana brands. But it's $47.55. So, okay. All right. Let's pop that back over there. All right, let's see here. What about using a down spiral? Aaron, we don't want to push the chips down in this case, okay? Especially with metal. We want those chips out. Now, also, very important, I almost missed one whole important thing. Bear with me. But Aaron, we don't want pushing the chips down. We need those chips to be pulled, lifted away. We need to use that upcut bit and everything. Now, the one thing that you want to do is, and there's a lot of different ones, brands and all that stuff, and everything, but let me pull this over. I'll just pull the whole screen over here. We want to drip a little cutting fluid when we're cutting. Now, it's going to be a little messy and all that stuff, but hey, it is what it is. But you don't soak it or saturate it, just a little bit. Little goes a long way, but we want some kind of cutting fluid. You could use, like a 3-in-1 oil and all, but you can also use actual cutting fluids. They have cutting fluids available at Lowe's, and you can get them, at hold on a minute. You can get them at Northern Tool. Sorry, if you have a Northern Tool in town, you can get cutting fluids. I mean, you can get cutting fluids anywhere, but a 3-in-1 oil will work too. But you want a little drip of something, right? When you're cutting, we're not doing massive cuts, right? We're just doing these little inlays and everything like that. But we want to lubricate a bit, and there's all kinds of Oatly, you can, it's like a thread cutting oil, right? You can use and things like that, or just cutting fluid. And Amazon has it and all that, but Northern Tool carries it $7.72. Magic cutting fluid at Reed Supplies, $3.61 for a small can. I mean, it's not something you're doing every day, right? But get you a little something. Now, I don't use cutting fluid. I use 3-in-1 oil, but that might not be the best practice, right? But it's a multi-purpose oil, right? It's a 3-in-1 lightweight machine type oil, and I've never had any issues with it, and everything. But hopefully some of this information is good and all that. So David Pingo asked, will a 1/8 inch shank with a 1/16 inch bit work? Yeah, I mean, if that's what your router requires, a 1/8 inch shank and everything. If it requires, or 1/8 inch shank, if your router requires that, then yes. But if you have a choice, if you have the ability to go with a 1/4 inch, absolutely, unequivocally go with the 1/4 inch. We don't want an 1/8 inch. That's just too weak. There's a lot of deflection and everything. On whatever shank we have out of the bit and all. It's just too weak. We want a nice thick foundation and everything. So if your router is a router that does accept or can accept 1/4 inch shank, absolutely unequivocally go with 1/4 inch shank. But if you're working with a router that has a small spindle type and all, and it can only accept 1/8 inch bits, then you can work with that too as well and all. It just control your feeds and speeds, your especially your feed rate. We got shallow cuts, always shallow cuts, right? We're only going about 20,000 7-inch per pass. And even though our material is only 0.028, so it's only going to be 2 passes anyway. But if we were doing something thicker, then shallow passes always. Ace is the place. Yeah, exactly. And Brooks, yep, 47.55 at Tools Today. Thank you very much. Yeah, Jeff, copper might age to a really nice patina. Troy's like, I better stick with silver paint. Right. Okay, let's get back to it, guys, because we're sitting here wasting a lot of time. But hopefully this time it wasn't a waste and you got some good information, right? So just so you know, the two tools that I'm referring to that I kind of would recommend, it's not, any O-flute 16th inch bit with 1/4 inch shank, carbide, not high speed steel or anything, that would be fine. But the Amana was, again, it was the 51488-Z, 51488-Z, toolstoday.com, $47. And the other bit was the Speed tool on Amazon, and it was the S1500, I believe. Bear with me, I'll find out. Speed tool, S1500. Bum, 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 bum. Did I have that number right? Give me just a second. Go back to the picture. SL 1500. SL. Dum, 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 dum. Give me just a moment. Give me just a moment. SPETOL. It does not like the name. So let's just do this. 1/16 router bit upcut 1/4 inch shank. Oh my. 1/4 inch shank, 1/4 inch cutting height. Yeah. It is $25.99. Let me pull it over here. Okay. It's $25.99. 1/4 inch upcut, 2 flute, 1/4 inch shank, 16th inch tip, 1/4 inch cutting height. And it's $25.99. And that would be for, that's a good bit for the aluminum. And you can also use the O-flute bit. So one or the other, right? I got both because I want to try both of them out. I work with the larger 1/4 inch O-flute bit, ZRN coated, for when I'm cutting like my metal aluminum gears and all that stuff, and it works great. So I'm curious as, the smaller bit and everything, I'm sure it's going to be the same well too, but I got this one also, So those would be, one of the two to try. You can do soft metals and everything with the 2 flute upcut spiral, that speed tool. So you could do the silver and the brass and gold and all that stuff as well. But the O-flute bit's kind of what it's designed for. Okay, enough of that rambling on. We'll get the inlay done here in just a second. Let's go back to our upper ring because we got some other additional vectors and stuff to draw. Now, on the fitted lid, gosh, I wish I had a sample to show you, to hold in my hand. Our lid, okay, is going to have the outside ring. I am going to do a slight pocket on the inside, not deep, but on the inside a slight recess, a slight pocket and everything. And that's going to fit, that outside ring, it's going to fit over a lip on that upper ring, right? So my inside wall, while it is 3/8 of an inch on that lid, that inside wall, that's not that outside, lip, right? So of that, and you'll see in just a minute when we create the toolpath, of that, okay, From my outside cut, I'm going to come in. I can go either direction, right? Which way do I want to go? And basically, on the upper part of the cut here, how much of my, I'll just use my soda can for a second here. How much of my lid is fitting over the lip on the base, right? How much, how deep, you know, and everything. And my lid is 3/4 of an inch thick. And so I'm going to probably go on my lip. I want it to be not too small, but I believe I'm going to go probably about 3/8, right? 3/8, you know, a little more than 1/4. So, when it, so that's going to be how deep the pocket is. That has nothing to do with the vector I'm about to draw right now. That's how deep the pocket is on the toolpath. But how wide, how thick of a little wall on that upper part, that 1/2 inch, you know, because I'm going to have my 3/8 inch walls are going to be the main ring, and it's only a 1/2 inch thick ring, right? And so on that top 1/4 inch portion of it, how thick is that wall from the inside to the outside where the box fits on there? And I'm going to go, since this is 3/8, I'm going to go half of it, 3/16. So I'm going to offset this circle. I know you're like, what the hell is he talking about? You'll see in 2 seconds. I'm going to go outward 3/16, 0.1875. Okay. And that is going to, my lip on the outside is going to be 3/16, and this is going to be 3/16 minus a few thousandths of an inch because we have to get it to fit together. But when we do our pocket cut, let me offset this one outward 20 thousandths of an inch, 0.02. Okay. And we're going to take this inside vector that I just created and this most outside vector here, and we're going to create a pocket cut going, now remember, this upper ring is only a 1/2 inch thick, right? So I'm going to go 1/4 inch deep, and I'm going to calculate that. First of all, got to make sure you use the right size bit so that'll fit, and that's not, 1/4 inch won't fit in that space there. So I'm going to use an 1/8 inch end mill. 1/8 inch end mill. And the 1/8 inch end mill I use, it's a speed tool. It's the extra long one with a 1 inch cutting flute, upcut. Two flute. I was trying to figure out what my flutes were. This is my lip pocket. We'll call it that. I don't know if that's the right term, but 0.125 end mill. And so, preview the visible toolpath. Okay, so we're going to have that lip. Let me turn off the color there. We're going to have that little lip there. Now, we're going to do our inside pocket, and it's going to cut all the way through. So we don't have to do it as a pocket cut. That's a waste of time. We're going to do it as a profile cut, right? Our profile cut. And just like we did before, we're going to select both the, not that one, our main outside vector, which is the outside of our canister, our lid, or our base, our box, whatever you want to call it. We're going to select that in that inside, and it's going to be a profile cut, just like we did on the little accent ring. We're going to cut a 1/2 inch deep all the way through. 1/4 inch end mill's fine for this. Outside right, remember I'm using two-sided tape, so this is going to be the profile cutout, and it's the upper ring. Good name. Upper ring 0.25 end mill. Now, I have, okay, here's the thing. I have an 1/8 inch bit with a 1 inch cutting flute. So I'm already using that 1/8 inch bit to do this little pocket. So I'm going to change this toolpath and use the same 1/8 inch bit to do the cutout a 1/2 inch because it has a 1 inch cutting flute on it. So I'm going to change that up for myself. And I'm going to calculate that. So that way I don't have to do a bit change on this particular piece. And again, remember, it does an inside cut on the inside vector, outside cut on the outside vector. And when we do the preview of the toolpath, okay, now that is going to be my upper ring, and that little lip, that's what the lid fits around. Now, I have not done any allowances, right, yet. I have not done any allowances yet. Allowance means that that when that lid, when I use the same vectors to cut the lid out and everything, if I don't give some kind of allowance, then the parts they're going to be exact. They're not going to fit together. I gotta make one a little bit smaller, or you know, open up one a little bit wider. One or the other. I either need to do this ring or I need to do the lid, depending on, you know, what it is. I am going to, since it's going to be kind of the pocket, I'm going to use the allowance on the lid, not this ring. So I'm not going to do an allowance on the ring. I'm going to leave it as is, and I'm just going to do the allowance. You'll see it in just a second when we create the toolpath on the lid. It's going to be a small allowance, you know, like 0.02 of an inch, 0.002, just to overcut it, oversize it, just that whole opening just a little bit, so it's a nice friction fit. And I'm going to start out with a very small number because I'd like to be able to sneak up on the fit. I want that, you know, kind of that, almost that vacuum suction pop, you know, when I press that lid on. Not too much of a vacuum, but, you know, I want, because I've had lids where it has too much of a vacuum and you couldn't almost get them up because the vacuum like sealed it shut, and it was like you couldn't open it up. I had one that had to actually drill a little hole in there to let air in. But not too much, but I want a nice fit. I don't want the lid just falling off, you know, and stuff like that. All right. So we're almost done. Save your work. Yes, I haven't saved a darn thing. Let's go to File, Save As. Save early, save often, guys. I preach it, but I don't practice it as much as I should. I should do that. Shame on me. This is my round inlay, round metal inlay box. The more I think about it, is I don't, round metal inlay box. Save. The more and more I think about it is I would I'd love to do the metal, cut a metal ring out in a metal inlay. Not a metal inlay, but a metal ring out to have that accent ring, you know, that maple with a nice metal ring. But I don't know how well, because it's super thin, right? So I don't know how well it would show up. Okay, let's go ahead and let's come back over here. Now, these new vectors, this vector here and this vector here, I'm going to copy them over to my lid sheet, so I have them to reference off of. And I've got my bottom pocket cut, I've got my accent ring cut, I've got my upper ring and the lip cut. Now it's time for the lid. Now the lid, let's make that active. The lid here, we've got to, I'm going to put in some dowel holes for my two-sided flip. There and there. 1/4 inch dowels I use. I went and bought a piece of 1/4 inch metal stock, right? And I cut down, it's the same two I always use, but I cut down 2 pieces 1/2 inch long and 1/4 inch in diameter. That's what I use for my dowels. I drill 3/8 of an inch deep into my material, 1/4 inch deep into my wasteboard, and that way when I flip over onto those 2 pins, I don't bottom out. You know, they're 1/2 inch long, and I've got a special place for them on the shelf on my CNC. That's when I'm flipping. That's my pins that I use. I don't use wooden dowels or anything like that, which you could, but I just, I have little shelf pins and all. So they're 1/4 inch diameter, and we're gonna take the vectors, these vectors here, and we're gonna copy them to the other side. We're gonna take our little holes here, we're going to copy them to the other side, and we're going to create our toolpaths and everything. Now our inlay, might as well do the inlay. I'm going to do all of it with the same metal. If I was doing different metals, then it would be 2 separate toolpaths, but this vector is going to be used to cut the male and the female, right? And I have yet to create the sheet for the for this to get cut out on and everything, as far as the board and stuff, because I got to create the toolpaths for the male cut. Before I copy this over into a new sheet and everything, I want to be able to go through and clean up things and make sure everything is tight and right the way I want it and all that stuff. And we'll go from there. Now, the fillets that never got put into this, when I did that offset trim on these parts here, these inside corners didn't get their fillet, right? So I want to put the fillets on those parts really quickly. Those inside corners, they got trimmed. And now, keep in mind that one of the reasons why at the beginning of the video, when I was like playing around with the fillet size, 16th, and I was like, whoa, wait, that, 1/8 of an inch, and ended up on 32nd. Well, a 32nd is the radius of the 16th inch end mill that I'm going to be using, right? So those inlay pockets and everything, that's kind of what I want to work with. And, the same thing here on these corners. They're going to have that same 32nd inch radius. Prepping for that. And then these are going to be fine. These cuts here will be fine with that. And, yeah, should be good. On my 0.0625 diameter cutter, my 0.0625 diameter cutter should be able to get in there. Did I make it not wide enough? Okay, so that's gonna not be the that inlay, the bit's not gonna be able to kind of get up in there and everything. So I have a choice. I'm going to be using the inlay toolpath. The inlay toolpath, whatever it cuts for the pocket, it will match the cut when I do the male inlay. It'll match the cut identically for the male. So because the bit can't fit in there, I don't necessarily have to change my vectors. Because the bit doesn't fit in there, the toolpath will only create what it can carve and everything. And whatever cut it makes for the female pocket, it's going to make the same cut, but on the outer perimeter, of course. It's going to make the same cut for the male if you use the inlay toolpath, and it's going to match it up so the parts, fit. That way, because the male is going to be cutting on the outside of the line, the female is cutting on the inside of the pocket. Well, it will have that male cut that same path as what the female where it could reach. So I don't necessarily have to correct or change my vectors. 2 more fillets top right. Yes, 2 more fillets top right. Very good eyes. Somebody has got good eyes. There and there. Okay. Make sure I got all the way around. Good catch. Good catch. So, my little flowers here don't quite, meet up to a match up to the 16th inch bit, but I could. Let me see here. Let me see if I even want to mess with that. I don't think it'll let me do what I'm about to try to do. 0.625. No, it's not going to let me do what I want to do. I thought it was going to let me do what I'm going to do, but it won't let me do what I want to do. All right, so here's what I'm going to do. Okay? Just quick and simple, quick and dirty. Okay? I'm going to take my bit here. I'm going to bring it up here. Bear with me now. Bear with me. I'm going to take a straight line right down the center. I'm going to take that line. I'm going to copy, Control C, paste, Control V. That copy that's selected, I'm going to hit the number 0 key to once. And I got to get everything centered because remember my line, I didn't draw it like the right length and all. That's why it looks off. You're like, whoa, he's way off. I'm not way off. But I'm going to take this and let me go sideways with it. Bear with me a second here. There. I'm going to align it up and down on the center of my material. This one's already centered left to right and all that good jazz. I'm going to select both of these guys right here, and I'm going to hit the number 0 key one time, right, to do that 45-degree turn. And, of course, I'm rotating off the wrong pivot point now. Let's go to the rotate tool. Use the center of the part. Come on now. Oh, geez, lady. Hold on. I'm at 2.625. Let me make sure I'm centered here. Quit playing around with me now. All right. So these two parts, the center, I got to move the pivot point up here. The reason why it's not centered is because this piece needs to be centered up and down. There we go. This one, left to right. Beautiful. Okay. Now, when I select those, my center better darn well be centered. It was off because my line, the length of my line and all that stuff, and I had it crooked. Okay, anyway, sorry. I'm going to hit the number 0 key one time. Okay. And what this does, okay, what this does is I'm at the center of that arc there, right? And this gets me a center point that I can snap my circle to, right? I can snap my circle to that line because I have smart snapping and geometry snapping on and all that happy jazz and all that stuff. What I want is I'm going to basically kind of be trimming. Let me go here. And stay there. Give me just a second. I'm kind of being a baby about it. All right, I'm going to bump that up there. And what that should do is, and I'll hit undo on this, but that should let me just kind of come in here and trim this away and then trim this away just to kind of recreate that shape, right? But before I do that, Let me put that back and all. Before I do that, I want to take this circle that I just created and I want to hold down the control key. Now, I don't have any magic angle for this line or whatever, so I'm just going to kind of pick a spot for it. Bear with me a second. You'll see what I'm about to do here in just a second. I'm changing my my shape of my flower here for a minute. So this is on the fly. And I'll work with that. Now I'm going to take that circle right there and I'm going to hold down the shift key, select this line, and I'm going to flip it using the mirror tool. Create a mirror card, flip about the line to flip it over there. Okay? Bear with me. Now I'm going to take all 3 of those circles and I'm going to rotate them using the circle rotate tool around the center of my board, that center point, 4 times around. I'm going to copy those around to the other 4 parts. Okay. Now, Big Fish is saying, no, 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 no. Wait, hold on. What kind of glue is used to hold the inserts to the lid? So the inlays in the lid, you're going to use either hide glue when you're doing the inlay or CA glue. So CA glue is a great for that metal inlay into the wood. CA glue, cyanaclate, something like that. Anyway, CA glue, or you can use the hide glue for it. It's a great bond. You need to, you're going to sand the metal that's going to get glue on it to scuff it up a little bit so it has some teeth. So a nice glue bond and all, but you'll use the hide glue or you'll use the CA glue is fine. But but you're going, Jeff's like, save, save, save. And then Big Daddy, you said, no, no, no. 2 more fillets, top right, and then question, exclamation mark. What was the exclamation marks? What am I missing? Let me know. But anyway, so I've got these copied around now. I can get rid of these lines. I just use them for my center layout there and also for my line to flip, right? And now I'm just going to go in and work my way around really quickly. I'm just going to go in and trim and trim, trim and trim. I've got a little bit of cleanup right there. Bear with me a second. Let's clean up that. That'll close itself off in just a minute. Let's do this one. Now, if I close that tool, it'll pull those 2 points together. Slightly a little bit of an indentation there, but I'm not going to argue with it. Over here, I'll have to, that overlap right there, that's what that little trim is. So I just got to remember to trim the inside line so it's consistent all the way around. So I'm just going to trim that, and then come in and trim the inside line and the inside line. And when I close the tool, it should pull those lines together. Okay, so just very quickly, I'm going to work my way around, zoom in, inside line, inside line. I got the box check to rejoin when the form is closed, so it'll join those lines together when the form is closed. So I'm going to come over here and trim, zoom in on the side ones, trim that inside line, I know you're all cringing, but we're going to close that off, and that'll close them up. Not much of a little jag there. You can barely see that. Come in here. Scissors. We're going to trim. It's consistent all the way around if it's one or the other. I could have, if I would have spent a little bit more time on it, I could have lined up on my tangents of the circle, and it would have been, just a simple trim like that. But I was slightly off. But go in, keep it consistent. Inside line there. When you close the tool, it'll pull those corners together. One more. then we got to move on because it's already 9:34. This project shouldn't have taken that long. It's a very simple little box. I think I talked too much. Is that what it is? All right. So let's go there and then trim, zoom in, get yourself zoomed in there, and straight line. Do it. If you're going to do it on one, do it the same on the other. And that'll pull those lines together. So that'll close that up. Now I got kind of little fillets that my router bit can fit into. All that happy jazz. Everything is good. We're golden. Okay. Let's create the inlay. Now, if I was doing two separate inlays, I'd create, I'd select the vectors for, the one metal, like if I was going to do like silver and brass or this or that, but I'm doing all silver. Okay. It's going to be the most expensive box lid around. All right. So we're going to do that, and we're going to do a inlay toolpath. Always an inlay toolpath and everything. So that way it creates the male and the female consistently for you. All right. This is going to be the female pocket. And our part is the material thickness. It should be pretty consistent in thickness from the factory. But I mean, it's metal and metal pressing and stuff. It might vary some. But that 22 gauge is going to be around 28 thousandths of an inch, 0.028. And so the it's not like a wood inlay where we are gonna press in that inlay and then have a little bit of lick sticking up and then sanding it down to be flush with the wood, right? I'm going to set the toolpath for the depth, 0.28. Now, if anything, I would go backwards, or I'd go deeper, right? Very small amount if I was going to do that, a few thousandths. But I'm going to be taking a flat block of wood and a rubber mallet, and I'm going to be pounding these parts down in there, into that inlay and stuff. And so on the inlay pocket, I'm inclined, and this is why I wish the metal would have come so I could do these cuts. And I'd like to, when I come back from Atlanta, I'd like to actually be in the shop and we do some cutting on one of the sheets and stuff. That would be cool. But the pocket, I'm gonna just probably go 5 thousandths of an inch deeper. So 0.0285, and that way I could sand my lid, because I got to sand my lid and clean it up anyway, and that would bring it down to the metal. Or I could have my lid completely sanded and everything and just put the inlay in and not that. But I'm gonna be polishing that metal anyhow. Sometimes people don't want to sand, but I'm using a fine grit, and it's not like, 120 or anything like that. But some people, sometimes they don't want to sand the metals and stuff because it, leaves marks and all that stuff, but it doesn't have that, that actual finish and all, but there's going to be some, cleanup required. So I'm going to go 0.0285, and if my metal would have come in, I would have actually cut this and I would have had a little bit more exact, here's what I did kind of thing. But I'm just gonna go just 5 thousandths, a little more than human hair. I'm gonna go 5 thousandths deeper on the cut, and this is gonna be the inlay. We're going to use a 16th inch O-flute bit. That 16th inch bit is going to be taking past depth of, I don't want to change it here. Hold on a minute. Let me select it first. I'm going to edit it in the toolpath. I don't want to change it in my tool database, but it's going to be taking a past depth of 20 thousandths of an inch. We're going to be spinning at 18,000 RPMs, and we're going to be traveling on this about 35 inches per minute. And I don't want to plunge fast into my metal and everything, so I'm going to actually turn my plunge down I'm going to turn my plunge down, even though it's only doing, 2 plunges, right? I'm going to turn it down, slow. So I'm going to go really about 7 inches a minute on the plunge. And I'm going to go ahead and click OK. We're going to 0.0625 O flute. O flute. And calculate. Now, okay, so that's going to, let's turn that off a little bit so you can see very shallow inlay, right? Very shallow inlay. Again, CA glue is great, cyanacrylate, and hide glue, one of the two for your inlay will be just fine. Now, I need to take that and I need to copy it to a new sheet. But I need to create the sheet first. Sheet. Add new. This is going to be my silver sheet. It's going to be 6 by 6. And it's, I'll caliper it and everything, but I'm just going to go what, the jewelry manufacturer says for now, but 0.028, 0.028. And click OK. Now, this cut is not an inlay, is not like a V-carve inlay or anything like that where we have to mirror the part, for it mirror to fit. We just need to copy the part over. We don't have to mirror it or invert it or anything like that. You guys and girls still with me? Yeah, Keith Painter, you're right? Why draw what you can copy? Why go through and fix all 4 when you could just fix one and recopy all 4 of them? That could have been done, right? My mind was not 100% on, on that. So, yes, I could have just fixed one, deleted the other 3, recopied them around, right? Why draw what you can copy? Why, waste time? So, Keith Painter, 100% correct. I could have done that. Absolutely. Without a doubt. Work smarter, not harder, right? Okay. I just wasn't thinking at the time. All right, let's select that and let's copy that to our sheet. Okay. Now, before we go over and create the metal inlay, let's finish up this sheet here. All right, so the only thing that's happening on the top is the that's what it is. The inlay, and we're going to do the inlay on the top, and then we're going to profile cut half the material down, and we're going to do the alignment pin holes. So let's start with the alignment pin holes here, and it's going to be a drilling operation for me. We're going to be cutting on this 3/8 of an inch deep. I'm going to be using a 1/4 inch end mill, and I'm going to peck it, peck cut it. And this is going to be my project board alignment hole. So I name it usually project board alignment holes or waste board alignment holes, depending on which one of the two it is. 0.25. And we'll calculate that. Okay, so that'll create those pinholes and everything. The profile cut, not that one, that one. The profile cut is going to be cutting halfway through on this side, halfway through on the other. Or I could just cut all the way through on one side. I just like a little relief and everything, so I'm going to just cut halfway through on one side, halfway through on the other. So we're going to go 0.375. We're going to be going with a 1/4 inch end mill on the outside of the cut. And this is side 1, profile cut out, 0.25, calculate. And so I'll have the profile cut will be last, the alignment holes will be first, and then the inlay. So we'll have these 3 cuts for side 1, right? Okay, so just that. All right, cool. Now, that's going to get flipped for me. It's going to flip on the y-axis. And in here, we're going to do a wasteboard alignment holes. So these holes here, that's going to be a drilling operation. It's going to be 1/4 of an inch deep. I drill 1/4 of an inch into the wasteboard. And I'm going to use pecking. And this is my waste board alignment holes. Calculate. And I don't need to preview those because they won't actually be showing up on the board. Now, my inside pocket, right? My inside pocket, just kind of want a little bit of a relief. Little relief on the inside pocket. A little bit of an opening. A little bit of headspace, if you will. So that inside vector, I'm going to just do a pocket cut. And this is 3/4 of an inch thick. I've got an inlay, only 28 thousandths, 28 thousand. I could go deep with the inside if I want and all that stuff, but I really just want, I really just want to go about, 3/16, 5/16, something like that. Just a little bit of little space, and everything. And, that's going to be beyond the 1/4 inch cut, right? So you remember there's a lip that this lid gets cut on. So that's going to be on this toolpath here, right? So from here, this cut, okay, this cut here is going to be cut 1/4 of an inch deep. That will fit. That'll correspond with the upper rings 1/4 inch, that outer lip, if you recall. So that will be 1/4 inch deep. Now, I don't want it to bottom right out at 1/4, right? I want to give myself a little bit of room, but I don't want to give myself a bunch of slop, right, at the same time. So my pocket is going to be, maybe at the most it would be 0.27, just another 20 thousandths of an inch more. I could go 0.3 but that just gives a lot of room there and everything. But I'm going to just go like 0.27, 0.28, not too much more than that 1/4 of an inch. And the bit that I'm going to use, because all of this is getting pocketed, right? So I'm going to use my 1/4 inch end mill, right? So remove that, go back here, 1/4 inch end mill. Okay. Now, I haven't put the allowance in yet. Remember if you recall, if you're thinking you're like, hey, he didn't put the allowance in, you're right. Those alignment holes won't be there. They'll be on the wasteboard. But anyway, I'm going to cut this with a 2/1000 allowance. Remember, it's cutting on both sides, right? So when it's offsetting 2/1000 over here, it's offsetting 2/1000 all the way around, right? So that's like almost like 4/1000 of an inch. And that's going to be my starting allowance. If I don't put an allowance on this, when that goes to fit on that lid and everything, it's going to be a tight fit if I don't put an allowance on there. So your allowance is always going to be a negative number. Okay. Now, the only time that's not true, is an inlay. When you're doing an inlay and you're overcutting your pocket for whatever reason, if you're putting an allowance in an inlay, it's always going to be a positive number. It could be positive or negative. It's always going to be an overcut. You're oversizing. Okay, your oversized allowance. It's actually referred to, if we go back and look at the inlay toolpath, it's actually referred to as an overcut distance. Okay, positive or negative number, it's not going to go in. It's always going to go out. It's going to overcut. It's referred to as an overcut. It makes it bigger, right? If you need to make the inlay bigger. On our pocket, we can make our pocket smaller or bigger. So it's a pocket allowance. If I use a positive number, that pocket's going to be smaller. If I use a negative number, the pocket's going to be bigger. And you're like, what? That sounds backwards, right? So when that bit is cutting on the inside of the line, a negative number takes us over the line. Anytime you want to cross over the line, it's a negative allowance. Anytime you want to stay back from the line that you're cutting on the inside of or the outside of, when you want to stay back away from the line, it's a positive number. You're positively moving back, right? Okay. So in the case of us, our allowance is going to be a negative number, and it's going to be negative 0.002. Okay. And this is going to be my lid pocket, lip pocket, 0.025 in mil. All right, so when we calculate that, I'll show you in the 2D view here. When we go into the 2D view, if I go into solid view, if we zoom in, it's going to be overcutting. Oh, not that much. It's going to be overcutting that 0.002 of an inch, right? That's super, super fine. But remember, it's doing it on both sides. It's doing it all the way around, right? So it's opening that hole up all the way around, not just one side, both sides. So that's like 4,000, if you will, right? If you doubled it, right? So that's going to be opening up all the way around, and we're good to go. Okay, so that gets the allowance. The male pocket on the upper lip does not, right? The part sticking up. Okay, so we got that. Now, my inside here, okay, let me turn this off. My inside vector, I want that to go deep. Now, I'm already at 1/4 of an inch, but I want to go another, from that 1/4, I want to go another, 3 or 5/16. So I've already pocketed out with this lid pocket here. So this inside vector is going to start at that 0.28. 0.28, that's where it's starting. And it's going to cut another, and in my case, I want to go, I'll go 0.1875, 3/16. Do I want to go 3/16 or 5/16? I'm going to go another 5/16. This will be my lid center pocket. Lid center pocket. 0.025 in mil. 0.25 in mil. Calculate that. All right, so that's going to create that further pocket there. Okay, just gives me a little bit of headroom in there, right? Now, the final profile cut. We're going to be cutting 3/8 of an inch deep, because remember, we already cut halfway through on the other side. 3/8 of an inch deep. We're going to use our 1/4 inch end mill outside of the cut. And I've got double side tape on this side as well too, right? So I'm not too stressed or concerned about glue residue on my inlay and all that stuff and everything. It'll be fine. You know, acetone and all that stuff wipes off right off. But anyway, so this is going to be my lid profile cut. Lid outside profile cut. And I have no real naming convention for my toolpaths. I just name them what I know, so I know what they are, right? Calculate that, and that's going to be our profile cut to cut out. It's going to cut that 3/8 of an inch deep. So you'll see the two tones there, where one's cutting halfway on one side, one's cutting halfway on the other side, and everything. And all the software showing you that. So this will be my lid, so that'll be the top. Now, I'm kind of, it's not sexy enough for me, right? I want to round it over. I want a nice little round over on this side. So I want to soften those edges up a little bit. But in the inside, it's going to be fine. And if I wanted to put a little inscription in there, I could, you know. I could V-carve a shallow inscription or something like that for someone. Whatever the case may be. And all. I could decide, you know, if I'm going to go big, go home, you know. But I think this will be adequate enough for a nice little decorative inlay inside that walnut and everything. It's going to be, you know, on... There's my walnut. Preview this, and this. Preview all sides. I was wondering where my walnut was for a minute there. It was a little bit of a delay. All right, so while that's cutting out, let's see what we got here. Keith, yep. Yes. Did you want to go 0.005 deeper or 0.0005 deeper? Can you personalize the inside lid with a V carving? Yes, I can go personalize the lid with the end carving, Big Daddy. And Ed, did I want to go 0.005 or did I want to go I did not. 0.0005 is 5/10,000ths of an inch. I want to go 0.00. You're right. 0.0285. I wanted to go. I did go. Don't confuse me, Ed. I did go 0.0. Let's go to the inlay. Let's go to the inlay side one. Let me flip back over to the side one. And I might have said the word 5/1000ths of an inch when I was describing it. But the actual toolpath, I went 5/10,000ths of an inch, right? So 0.0005 is what I added to that 0.028. If I would have added 5/1000ths of an inch, which I did say verbally, I know that now because I did say that verbally. If I would have added that, then that would have changed my cut depth dramatically. It would have changed it to, you know, 0.32 and everything, right? And that would have been a little bit much. But I literally just want a small amount. 5/10,000 of an inch. It's insignificant, it seems like, and all, but it's not. Because I got a block on top of my inlay, rubber mallet, pounding it down. As I glue it in, it's going to seat nicely and all that stuff, but I'm just going a little bit deeper. Now, if you feel that, you know, I want to go 5/1000ths, 0.005, you can add that to it and everything. I just don't know yet, right? And I'm going to sneak up on it, right? I won't know until my metal arrives. I'm actually out in the shop and everything, but right now 5/10,000ths of an inch. So Ed, that's what I typed in, but I verbalized it incorrectly. Thank you for pointing that out to me. Thank you. I appreciate that. Okay. So in here, back here, All right, so we got my inlay, and on that inlay, right? Let's see here. Let's see if I can. Let's see how good I am. Inlay, toolpath. Let's simulate. Right. So it'll have that silver inlay, and I will decide if I want to go a little bit bigger, you know, scale it up a little bit more. I don't know. Oh, I do want to do the round over, so bear with me a second. I want to, after the alignment holes, I want to do the pocket inlay, and I want to do that halfway cut through on the first half. And then I want to do a profile cut. I want to go 1/4 of an inch deep. I want to use the white side 2050 round over bit. It's an 1/8 inch radius round over bit. I want to cut on the outside right of the line, but I want a pocket allowance offset of negative 0.125. That's the step over for the 2050 round over bit, 1/8 inch radius, and I want to round that over, and I want to calculate that, preview that visible toolpath to give that lid just a little round over. Right. Now, if I wanted to get more funky or technical with it, I could do a little OG round over and all that stuff. I just got to remember how much meat I have here, right? So I don't want to get too deep into it, and and all that stuff. Just make sure I got enough meat and all. But just a nice little round over or something, and everything. I could go from there. Now, how would a slight dome affect the inlay? Well, I mean, the metal is pliable, right? It's getting glued in with the CA glue and everything. So the metal's pliable and everything. As long as it's not too dramatic, right? Because we don't want to kink the metal in any way or anything like that. It's 28 thousandths of an inch, and it's pliable and everything. We just don't want to like it being too much where it's like, it's too kinked or too dramatic or whatever. We don't want to put too much surface tension on it. The CA glue and everything should hold it into place. But we can always, it's a soft metal. It's a dead soft metal, and which makes it easy to cut. It's very pliable, very workable. And everything. And I mean, they shape it into rings, right? This is the same metal that you get shaped into rings and necklaces and jewelry and all. So if you decided to go with a slight dome, that wouldn't be a problem. The only thing is now, okay, you need to create, you're taking it out of Vectric, well, you're not really taking it out of V-Card, because you can use the dome and dish tools to create the model. And then the toolpath, the inlay toolpath, I believe the inlay toolpath has a option to project onto 3D model. Let me see here. No, it doesn't. So, you don't have that option to project onto a 3D model, so it follows that curve. So I really don't know how you would work that. How to create that pattern to follow that dome. The inlay pattern itself, because the inlay doesn't have it. Now, a pocket cut does, okay, let me say this, a pocket cut does have project onto 3D model, and essentially the inlay, that's what we're doing, is a pocket. But the inlay toolpath, its specialty is if it cuts the pocket a certain way, it creates the mel cut in the exact same way. Like if it has to create a, you know, a fillet somewhere where, you know, because it couldn't fit into a corner or something like that or whatever. It creates the male cut the exact same way so the two parts fit together flawlessly. If you did the female as a pocket cut and you're doing that pocket cut over a dome, well, now you're stretching the vectors. So that in order for it to follow the curve, it's stretching the vectors. That male cut's not going to cut with those vectors stretched like that. So I don't know how well that would work, buddy. Sorry. Something you could try, but I wouldn't try it with a $144 sheet of silver metal. Right? Get some scrap aluminum. Yeah. Now, this design, I went with this design while I'm here really quickly, and then we can wrap up because it's 10 o'clock. With that, that's going to kind of complete our box and all. Everything gets glued together. Your three layers, your base is the bottom pocket. The accent ring gets glued to that. Upper ring gets glued to that. And then your lid, fits onto that stuff. But I think really quickly, I'm going to take this object here. I'm going to hold down the shift key and I'm going to scale it up a little bit. I'm going to go over and make this sheet active for a second, the silver inlay. It's going to be an expensive box for sure. Delete that, come back over here. And right click, copy to sheet, silver sheet. All right, let's go back into the inlay tool really quickly. The inlay toolpath that was created already. The vectors, all I did was scale them up, so they're still selected, so I'm just going to recalculate that. All right, reset that preview. Preview all the toolpaths. Yeah. I think that looks more appropriate for the lid. The other one was just a little bit too small. And I did get a 6" by 6" sheet, so I have plenty of room there. Because that inlay is only 4 1/4, a little under 4 1/4 by 4 1/4. Okay, last thing. Come over here. Into our silver sheet. Get this centered, not centered, sorry. Get this positioned in a way that I can minimize my waste and maximize my yield, right? Now, these parts are getting cut out, right? All these little parts are getting cut out. They're going to still be glued to the MDF backer board when it gets cut and everything until I separate it, until I soak it in water and separate it all. Now, I'm almost wanting to nest this to minimize my waste and maximize my yield on this part because of the cost of the sheet and everything. But at the same time, these parts should all be consistent, right? They are copies of each other. They should be consistent. So I should have no fear of breaking this up and nesting it to minimize my waste. Or I could just cut it out as is, right? I believe because, and I'm just gonna, I'm gonna test my theory really quickly here. I'm gonna take a line. This is how I do my test, okay? I'm going to take a line from the center of my board. Let me make sure. Let me get centered here. I'm going to center on the material. Okay. I'm going to take a line, and I'm going to just snap to the center, and I'm going to draw a 90-degree line straight out, or 0-degree line straight out, space bar to finish. I'm going to take this part right here. I'm going to select that line right there, and I'm going to flip it about that line. I'm going to create a mirrored copy, and I'm going to flip it about that line. Or actually, I'm not going to create a mirrored copy. I'm just going to flip it about that line. And it should land close, right? Not exact, but close. Should land, should have landed somewhere close. But let me see here. It gets me in the right orientation, at least. If I drag that up and kind of snap that in, they're not the same, right? So undo that. Now, that piece and this piece should be the same. This piece and this piece should be the same. So let me take this piece. I'm going to put everything back. Control Z is your best friend in this little scenario. I'm going to drag the pivot point down to this corner here. And I'm going to pivot this bad boy around here. And I was off on my pivot a little bit, but I was close enough. All right. Let me pivot that some more. Okay. So those two parts fit, right? So this part fits with this part fits with that part, so on and so forth. And let me undo everything here. Let me take this and this line, flip it about that line. Okay, and that lands, that lays out perfectly there. Okay, so it wouldn't be too hard to, get the fitting pieces in the fitting parts, right? Because it's just every other piece that, this piece will fit in that hole, that piece will fit in that hole, that kind of thing. It's not like I'm doing a big major project. It's just this. So knowing that and everything, I could take my parts and nest them. I'm going to be using a 1/16 of an inch end mill, and somebody might be like, "Man, I'm not even going to deal with that," right? But they're consistent somewhat. So the clearance, I can keep my clearances tight because of the simple fact they're all glued down, right? They're glued down to that MDF backer. They're not free floating and flying everywhere and all that good stuff, right? It's glued down, so when it cuts out, it's still going to be attached to the backer board. So I can go on my clearance. I can go a 1/16 of an inch. And my edge, I'll stay away from the edge a little bit. 32nd. I'll let it rotate in up to 10-degree increments. I will rotate for best fit, remove the parts. I will nest direction from the bottom left corner and along the X, preview. Okay. And so that will lay out those parts to get cut. And that doesn't intimidate me, right? And that gives me, because again, it's a $144 sheet, right? You want to minimize your waste and maximize your yield, right? I want to minimize my waste. Now, if I go and cut this, and you might not want to do that, right? It might be better for you to just cut it out as is, so you know what parts go where, right? But here's the thing. I don't know if the metal floats. I don't think it floats, or else we'd have gold floating in the ocean, right? But when it separates from the MDF in the bucket and all, depending on how it's sitting, those parts are going to fall off, right? And, you know, they're going to probably get mixed up anyway, right? All right, so let's click preview. Okay. All right, let's select all this, or first of all, let's select all duplicate vectors. Make sure there's none. Wonderful. Okay. Let's go ahead and profile cut. Cutting 0.028. You can go a little bit more if you want, but I'm going to go 0.28. I'm going to be using my 1/16 of an inch O-flute bit. I'm going to be, that metal cut is going to be 35 inches per minute, 18,000 RPMs, 32nd of an inch, and I'm going to go with a pass depth of 7 inches per minute. This is going to be my inlay. Select. And the great thing about this is you always want to use the same bit to cut your inlay male parts as your female parts. And because I'm using the ZRN coated bit or the upcut two-flute bit, either one, they both will cut wood. Because the O-flute bit is ZRN coated. It can cut wood and other metals and materials and all. So can the two-flute upcut bit. So I'm covered either way. I don't have to use one bit for one thing, one bit for another. I can use the same bit for both cuts. So let's preview the visible toolpath. And I'm okay with that because all that scrap left there, I've got half a sheet still here. I don't have that big medallion right in the middle, wasting out of it. I got half a sheet that I can use for another project or what have you. And whatever's left over here, I can melt down. So I'm good with that for the inlay parts. Yep, I'm going to be happy with that. Okay, so that's that, ladies and gentlemen. All right. Yeah, so hold on a second, Keith. Let me see what Keith is let me think about this for a second, Keith. Keith says with those parts being different, you could label them before nesting. Yeah, if I knew round about where they were getting cut and everything, I could label them. I could there's a lot of ways that I could approach that, Keith, right? I could cut it from the bottom side, upside down, or, make sure my good face is down or whatever when I glue it to the MDF or what have you. And really it's metal. They both have good faces. They're all going to get sanded anyway, but I could take my diamond bit and, number them 1, 2, 3, 4, 5, 6, 7, 8, that kind of thing. And etch it on there like an actual small little miniature number or a little mark or something to identify it. I could do that to identify the parts and all. But I have 4 parts that are the same on those smaller ones, and the other 4 parts are the same, so I just have to match those up with their holes. So one's a little bit longer than the other. So there's 4 holes that are longer and 4 holes that are shorter, and then everything else fits together. Fits right into one or the other. But I could etch a little number in there, and that could be the bottom side that gets glued in the inlay. You never see it. I could label it somehow or another. I could mark it and everything, but I'd have to mark it before I unnested it, right? So I'd have to write the vector in there, what the part is, and then group those pieces together and then nest it so it groups together with the appropriate number, right? So yes, there's a lot of ways that you could approach that. Let's see here. You guys are welcome that are thanking me and all that good stuff. Thank you. Thank you for Roger Brown. Thank you for the super chat and all that stuff. Appreciate that. And Keith Troy, let's see here. I was thinking the same thing. Maybe use a marker to separate the small parts. Like 1s and 2s. Group the numbers to the shapes, then nest. Right? Yes. Group the numbers to the shapes and then nest. Right? 1s and 2s. But I could... yes. So I could nest them and I could mark them and everything. 1s and 2s and all that stuff. If it was a huge kind of like a puzzle piece and all, and everything, then I would definitely, try to work out some kind of system like that. For these few pieces, the 4 big pieces all fit the same. The 4 leaves all fit the same. I've got 4 large half arcs and I've got 4 small half arcs. So it's not that difficult to, mark. But if it was a lot, then absolutely. Or I just bite the bullet and not nest it, and all that stuff. But I'm a big fan of minimizing waste, and that gives me a whole half a sheet to do something else on, and that makes me happy, right? And it makes my box less expensive. Literally, because I can use that other, for something else. So this part, we have a 1/2-inch sheet thick or 1/2-inch piece of material for our upper ring, 1/4-inch piece of material for our accent ring. Now, if you don't have like a ways to surfacing or planing these down or making these thicknesses of material and all that, use your CNC, right? I'm using double-side tape. So, or a bandsaw if you have a bandsaw or whatever, but you can use your CNC. So I have double-side tape holding these. There's no clamps in the way, so I could surface down, a 1/4 inch of to a 1/4 of an inch thick material, 1/2-inch thick material, and that kind of thing. On the accent ring, it's only a 6x6. Hell, you could even use a dovetail saw, or a pull saw, or band. What if I didn't have a bandsaw? That 3/4 inch thick piece of material, if I didn't have a way of planing it down, I would at least want to kind of rip it in half because it's going to be 1/4 inch thick, right? I don't want to waste, a 1/2 inch of material that I could use, somewhere else on the walnut or whatever. So I can mill it down, and then flatten it out to 1/4. I could get it to the finished depth before I cut it out and things like that. There's a lot of ways to do it. Your CNC can be your planer, and if you don't have, ways of getting your material down to the thickness you need to, use your CNC. It's a, profile cut surfacing toolpath, and you're good to go. Good evening, Jeff. How are you doing? And Jeff says, I have a 14 shelf pin, 1/4 inch diameter hole to drill. What is the best tool path for drilling the holes? Good night all, good luck, and all that stuff. Let me say this. If you're going to drill your 1/4 inch diameter holes with a 1/4 inch bit, drilling toolpath is the way to go. Use pecking. Okay. If you're going to drill the holes with an undersized bit, it's not drilling, it's pocketing. If you're going to pocket the 1/4 inch holes with like an 1/8 inch bit, that way, bear with me a second, then the pocket toolpath is the best way to go. Now, the advantages, right? If your machine, depending on the rigidity of your machine and also how fast you're plunging in on your cut on your drill, I would recommend like a 10-inch a minute plunge. When that bit comes down, okay, if there's any flex or anything like that in your machine, if you're doing a drilling toolpath, right, and that bit is flexing as it's, you know, drilling down and everything, then what that's doing is it's wallowing out the holes. Okay? It's wallowing out the holes. So using an undersized bit, like an 1/8 inch bit in that 1/4 inch hole, you're starting in the center. If there is any flexing, it's now pocketing out, and then there'll be some relief, and that hole will stay straight all the way down, right? So if you're drilling those 1/4 inch holes with an 1/8 inch bit, pocketing them, not the word drill, pocketing them, then, you know, you have a better chance of a perfectly sized hole, nice and clean and straight, right? Drilling toolpath, depending on the rigidity and your machine and all that stuff and how fast you're plunging in, if there's any flexing on the first pass or all the passes or whatever, then it could wallow out that hole, and then that makes it sloppy for your shelf pins, right? These shelf pins have to hold the shelf, and if there's any slop in those holes, then the shelves are now rocking, right? And if this is 14 rows of shelf pins for adjustability, that's a pretty decent sized shelf or a decent sized cabinet. I personally, if you were asking me, it would be a pocket toolpath with an undersized bit, 1/8 inch bit. Okay. All right. Key says, we wouldn't be in this predicament if we drew one and rotated. LOL. You're absolutely right. All right. With that, we are done. Dun, 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 dun. All right, that is it. So hopefully you like this toolpath. Definitely check out, now I want you guys to definitely check out the episode 6. The video link is in the description of this video, but episode 6 of Metal Inlays of Woodsmith, that CNC Base Camp. Listen to the video. He also shows his little box, right? And he talks about his little box that he makes. It's a neat little box and all, finger box and all, with a nice fitted lid kind of thing. Gravity is what holds it on. And also the shape of the contours of the top and everything. But watch that video and watch how he does his inlays, how he talks about his backer boards, hide glue, and all of that stuff. And, you know, it's a great video. It's a great tutorial. There's some good files that are provided to you. Where are they at? Import. There we go. There's some good files that they provide to you and little patterns for inlays for some floral stuff, right? And this little box detail, nice little finger box and lid and everything. It's 4 separate pieces. They get glued together and all that, finger joints and stuff. But watch the video, episode 6. Link is in the description down below of this video, and definitely check it out. These files right here, the vectors for these files will be saved and also available for download I'm going to clean up the file names and all that stuff, and the layers and the lid names and all that stuff. But they'll be available for download as well, so you can download this also. And Keith, if you do download it, delete and recreate your shape so you don't have to deal with that predicament. But everybody else, you know, you can use that. There's no predicament. It's all good. But thanks for your comments. Thanks for correcting me on things and giving me insight when I'm not thinking and all that stuff. Really appreciate y'all's feedback. Thanks for the support, for watching and hanging with me. And with that, you guys and girls, have a great night. Let's see here. Sorry, on the other guy at the indie show. Yes, if you're going to be in Atlanta, I'm going to be at Atlanta. I'm leaving for Atlanta tomorrow. I'll be at the Atlanta Woodworking Show all weekend, Friday, Saturday, and Sunday. The Atlanta Woodworking Show. If you're in the Atlanta area, come on out and see us. We'll be there. I'll be there. Okay. Oh, really quickly, let me just give a quick shout out before you guys and girls really say goodbye. Let me give you just a quick shout out on the shows that we're doing. We added 2 new shows to our lineup. for those of you that would like to come out and see us or see digital wood carver and all. But we will be doing the New Jersey show February 10th through 12th, the woodworking show in New Jersey. We'll be in Milwaukee February 17th through 19th. At the woodworking shows, we're going to be at the Northeastern Woodworkers Association show in Saratoga Springs, March 25th through the 26th. Those 2 days, 25th and 26th. And then we also are going to be at the Woodworking Show of Texas. Now, that's not the Woodworking Shows. It's a completely different show, but it's the Woodworking Show of Texas in Houston, Texas, April 28th through April 30th. So, definitely, if you're in those areas at those times, come on out and see us. We'd love to see you. Say hi, and let's talk CNC. All right, everybody. Until next time, I'll see you soon.